Hello, hello, hello. Hello, hello, hello. Yes, it is working fine. Hello, dear students. Welcome to Unacademy NEET English channel. Students, today we are going to cover two very important topics. These are the starting topic of physics, which are basically not the topic of physics. They are topic of the mathematics. One is the vectors, and the other is the calculus. Calculus part we were supposed to cover in the previous lecture, but because of some health issues, I could not cover the calculus part in the mathematical basic maths class. So today we will, along with the vectors, we are going to cover differentiation and integration and their application. So this lecture is going to be quite long, 5 to 6 hours long lecture. This will be the this lecture will be 5 to 6 hours long. So vector, like in NEET, in exam they directly ask question from the vectors. Differentiation and integration are basically behave like a tool, but vector is the part of your syllabus. They can ask question from this part as well. So you have to complete this topic in a great detail with so many illustrations, with in-depth knowledge. So that I'll try to cover in this 4 to 5 or 6 hours long marathon session. So I can see so many comments here. Are you excited for the session? Like I have always, whatever I have committed, I fulfill that. Like last time I said I'll cover the basic maths in a great detail, and that I did. And today also the same thing we are going to do. Vectors, we are going to cover this vector topic from basic to the level which is required for your exam. So I want all of you to share this session among your groups. Do not forget to like the session, share with in your community, and subscribe this amazing Unacademy NEET English YouTube channel. Don't forget to subscribe the channel, and don't forget to press the bell icon so that whatever sessions are conducted on this channel, you will get the notification for them. You would not want to miss any of the session conducted on this channel. On this channel, whatever is committed to you, every faculty is fulfilling that commitment with their great dedications. They are all regular. Last week I could not take one more class because of I was out of station. So this time I have two back-to-back classes, one on the vector and the calculus, and the other on the Cartesian thermodynamics. So we are going to start class 11th, two topics, starting topic, and parallelly I will be covering our end topic as well. So Cartesian thermodynamics is the end topic, so that we will cover in the next lecture. So please don't forget to like the session before we start the session. I'll share the PDF of the previous session along with this PDF, because in the previous session we could not complete the topic. That's why I did not share the PDF, but this time I'll share the PDF. Okay. Okay, so let's start the session. Are you ready for the session? Should we start the session? Good evening, good evening, good evening, everyone. Good evening. Okay, so let's start the session. This is a vector and calculus session. I'm Kailash Sharma, and we are going to cover these two topics in a great detail. So let's begin with vectors. So what are the topics we are going to cover? Like the previous classes, I always give the overview of the topics which we will be covering in the next 5 to 6 hours in this marathon session. First, we will talk about the introduction of the vectors. We will define the vectors, what are the vectors, and all the important points about the vectors. Then we will talk about the addition of the vectors, components of the vectors. You will be able to do component of the vectors, net force and displacement, product of the vectors. These all topics are from vectors topic. And then we will enter into the calculus part, which is the differentiation, application of differentiation, integration, application of integration, And if time allows us, I'll cover the logarithmic function as well. This is also sometimes create problem to the students when they don't have knowledge of the logarithmic function, log function. So I'll try to cover that as well. So idea is, after this session, you must be confident in mathematical part of the physics. In the previous class as well, I told you, mathematics and physics, they go side by side. You cannot leave one behind. Without mathematics, you cannot understand physics. So mathematics behave like a tool to understand physics, to solve the numericals of the physics. From the first chapter only, that is the kinematics, you will see a lot of application of the mathematics. Like you will find the questions on the vectors. If you don't have the knowledge of the vector, you will not be able to solve those questions. Differentiation, integration, function, each and every concept of the basic mathematics that is covered in the previous class and I'm going to cover in this class. You will be using that from the first lecture, first topic of the physics onwards. So let this topic take very seriously, and let's finish this topic first, okay? So first of all, I'm going to introduce the vectors. What are the vectors? What are the important points about the vectors? Before that, I want all of you to have a look at this. NEET Endgame, the ultimate crash course. At this time, many of you are looking for a crash course. Those who are preparing for the NEET 2024 are looking for a crash course. And this wonderful team brought up crash course for all of you who are preparing for the NEET 2024. You can join our crash course, the NEET Endgame, and there is a early bird price offer as well. This crash course is available at 7,999 rupees, and there is a referral code you can use, that is the Kailash 10. With this referral code, you get the maximum possible discount. Use this referral code and join for NEET Endgame crash course. So let's begin the topic, that is the vectors. So I told you, I already taught you the topic of units and dimension, where I defined the physical quantities and the types of the physical quantities. The quantities which can be measured are called the physical quantities, and we defined the type of the physical quantities like derived physical quantity and the fundamental physical quantities. But that classification was based on, that classification we did in the unit and dimension was based on the dependence of a physical quantity on the other physical quantity. Here again we are going to classify the physical quantities, and now we are going to say vector physical quantities and the scalar physical quantities. So that classification is different from this classification. Again we are talking about the physical quantities only, but that time we were talking about the we classified physical quantities based on the dependence of one physical quantity on the other physical quantity. So there were two types of physical quantities, derived and fundamental physical quantities. Here also we are going to do one more classification, and that is the scalar and vector physical quantities. What is special about this classification? Why do we need one more classification to define the vector, to define the physical quantities, and to classify the physical quantities? So physical quantities are of two types based on certain things. Okay. First one is the scalar physical quantity, and the second one is called the vector physical quantity. What are the scalar physical quantity and what are the vector physical quantity? So here is the definition of these. Physical quantities which have magnitude only and does not require direction to represent them are called the scalar physical quantities. So scalar physical quantities are the physical quantities which do not require direction to represent them. So basically, based on the requirement of the direction, physical quantities are divided in two categories, classified as scalar or vector physical quantities. So those which does not require direction to represent them are called the scalar physical quantities. For example, distance, it does not require direction. You just say, suppose my home is at 1 kilometer distance. So I'll say my home from this place is 1 kilometer far from, my home is 1 kilometer far from here. Yeah, the distance of my home is 1 kilometer. I don't have to specify in which direction is my home. So this is, distance is scalar physical quantity, volume is a scalar physical quantity, density, mass, time, pressure, speed, work, power, area, current and charge, they all are scalar physical quantities. You don't have to define the direction for these physical quantities. Okay, so those which does not require direction to represent them are called the scalar physical quantities. And what about the vector physical quantities? Physical quantities which require magnitude as well as direction to represent them are called the vector physical quantities. So those physical quantities which require direction along with the magnitude to represent them are called the vector physical quantities. So this classification is based on the requirement of the direction to represent a physical quantity. Then such classification is the, or type of the physical quantity is the vector and scalar physical quantities. Okay, there are few examples of the vector physical quantities which we will talk about in the physics topic, the physics next lectures. Position, displacement, velocity, acceleration, force, linear momentum, impulse, torque, angular momentum. These are the few physical quantities which are the vectors. So these are few examples only. Okay, so some example of the scalar physical quantities are given, some examples for the vector physical quantities are given, and the definition of both is clear to all of you. Is this clear to all of you? Is there any confusion about the scalar and vector physical quantity definition part? I hope there would not be any confusion till now. Okay, is this clear to all of you? This is the introduction part. This I have defined the scalar physical quantities and the vector physical quantities, or we say the type of the physical quantities. Both types I have defined, but there are some exceptions as well. Just one student mentioned about it. There is a scalar physical quantities which has direction as well as magnitude, and that physical quantity is known as current. So current is a physical quantity which might confuse you. This physical quantity might confuse you. Why? Current has a direction as well as magnitude. So will it be a vector or a scalar? Current has direction as well as magnitude. So according to that definition of the vector, this should also be the vector physical quantity. Current should also be the vector physical quantity according to our definition on the previous page. What did we say here? Physical quantities which require magnitude as well as direction to represent them are called the vector physical quantity. Either this definition is incomplete, that will be the case otherwise, because we have written current on this side. We are saying current is a scalar physical quantity. Current we have not written on the vector physical quantity side. So current has direction and magnitude both. Then why current is written on the scalar side, not on the vector side? What is the problem with the current? So basically that definition will confuse you if you don't add one more thing into it. And what is that one thing? Basically, while adding the current, suppose there is this wire and there is this wire. 1 ampere current is flowing in this wire, and suppose 2 ampere current is flowing in this wire, and we add, because these two current will add here, this current will be equal to 3 ampere. So it hardly matters, their directions hardly matters, in whatever direction they are coming, it will always be 3 ampere. Like if you say the 2 ampere current is coming like this, or 1 ampere current is flowing like this, then again this current will be equal to 3 ampere. So it is not obeying the vector law of addition. So there are certain laws to add to vectors. and it is not obeying that. That's why current is not a vector physical quantity. We are just simply adding the magnitudes of the current when we are finding the resultant of the two current or net of the two current. So we need to do some changes. We need to add something in this. Physical quantities which require magnitude as well as direction to represent them are called the vector. We have to add one more point into this. For a physical quantity to be a vector, it should have magnitude, okay, direction, okay, and must obey vector law of addition. So that definition is kind of incomplete definition for a vector physical quantity. So we need to add one more point into it. A physical quantity having magnitude and direction and obeying the vector laws of addition, then and only then that physical quantity is a vector physical quantity. Is this clear to all of you? So any physical quantity which has direction and magnitude cannot be said that it will be a vector physical quantity. Okay, so for a physical quantity to be a vector physical quantity, it must obey vector law of addition, but current is not obeying it. Current is simply getting added. On the other hand, the addition of scalar physical quantities, how do we add scalar physical quantities? Follows the simple rules of the algebra, and here only their magnitudes are added. So when we are dealing with the scalar physical quantities and there are two physical quantities and we are adding them, then we don't have to use special rules. We have to simply add their magnitudes using the algebra. Like 1 ampere current is simply added to 2 ampere current and it is giving the net current 3 ampere. We are not using any special rules. We are just simply adding using the algebraic operation, a simple algebra, and that is 1 ampere plus 2 ampere is equal to 3 ampere. That's why current is not a vector physical quantity. So is that clear to all of you? So the definition of the vectors and the difference between the vector and the scalar is clear to all of you. This is the only confusion which arises here. Current creates the problem with this definition. So this definition is contradicted by the current. Okay, so now will you be able to explain why current is not a vector physical quantity? It does not obey the vector law of addition. It's simply we simply add the currents using the algebraic expressions, and or you say we just add the current by adding the magnitudes of the current. So that's why current is not a vector physical quantity. Now the definition of vector and scalar is clear to all of you. It is the complete definition of the vectors. So vectors are the physical quantities which have the magnitude, direction, and they obey certain vector law of addition. So there is a vector law of addition. You add two vectors in a particular way that we will define, and that way should be followed by the vector physical quantity, and then and only then that physical quantity is a vector physical quantity. Okay, is this clear to all of you? Is this clear, students? So till now we have only defined the scalar and the vector physical quantities. So these are all the points we have to keep in mind, and I'll provide this PDF to all of you so that you can make notes at home. Let's move to the next point. So how do we represent a vector? How do we represent a vector? Representation of a vector. So vectors are represented by two ways. There are two different ways to represent a vector. One way is a vector quantity is represented by an arrow. We simply represent a vector by an arrow. Arrow points in the direction of the vector, and length of the arrow represents the magnitude of the vector. So let's say there is a point A and there is a point B. We have to draw a vector in the direction of B from A. So somebody is standing here, he is pointing out towards B and saying that there is a vector in this direction. In what direction? A to B. From A to B direction there is a vector. So how do we draw that vector? So to draw that vector we simply draw an arrow from A to B. So this vector is the vector which has the direction AB direction, and the distance, the length of this vector is the magnitude of this vector. Okay, so vector is a physical quantity, it must have magnitude. It must have magnitude. We measure that physical quantity. So what is that magnitude? That magnitude is represented by this length. So this vector is represented like this. So this is a vector from A to B. The direction of vector is from A to B. We can call it AB vector because this is from A to B. So we can call it AB vector, or we can give it a random name. Suppose I am calling it a P vector. I can call it P vector. I can call it AB vector, but I should not call it BA vector. BA vector is different vector. BA vector is from B to A vector. So I can call it AB vector, I can call it P vector, I can call it R vector, I can give any name to this vector. I can call it velocity vector. I can give any name to this vector. The length of this vector, so this arrow point in the direction of the vector. Length of this vector gives us the idea of magnitude. So magnitude of vector is represented by what? The length of the vector. So how do we measure? Like, so will I be measuring this length to measure the magnitude? No. This gives us an idea. Let's say there are two vectors, there are two forces. One is of 10 Newton and other of the 20 Newton. So what we will do, and they are in the same direction. When we will be drawing these two forces, we will keep this in mind that the other force is twice in the magnitude. So when I am writing this F1 vector, which has a magnitude of 10 Newton, then I will be writing this F2 vector, which has a magnitude of 20 Newton. So it should be double in the length. It will give you the clear idea that the second vector is has greater magnitude. So approximately, while drawing these vectors, you must draw this other vector twice of the length, or the length of this vector must be twice of this vector length, because this has double magnitude. So length must give you an idea. Length must give you an idea that this is the proper way of doing this kind of question, or drawing the vectors. Otherwise, some people just draw 20 Newton also, just like same length, but that is not the proper way of doing the question. So whenever you draw a force of 20 Newton and a force of 10 Newton in the same diagram, you have to keep the length of the 20 Newton force double that of the 10 Newton force. Try to keep these things in mind while drawing the forces and all, because from the second chapter onward you will be drawing force vector in the Newton's laws of motion and the friction. So keep this thing in mind. So the magnitude is represented by the length of the vector, okay? And this vector is like this. Magnitude of a vector is represented. So suppose I write this. So when we put mod, this is represent the magnitude of force vector. Magnitude of the vector, the force vector, is represented like this. So when I write anything like this, A vector, suppose, so this is the magnitude of A vector. This represents the magnitude of A vector, okay? So magnitude is represented like this. This is the other way of representation. So this is one way of representation, and the other way of representation of a vector is, there is one more way of representation of the vector. Sometimes we write a vector like this. F vector is equal to 2i cap plus 3j cap plus k cap. So we represent vectors like this as well, and this form is much easier to handle with. So we will be talking about this also. How do we represent a vector in this form? So first we will talk about this form of the vector, because most of the questions on the dot product, vector product, or addition are easy to handle if we are representing a vector in this form, I cap, j cap and k cap. But how do we form how do we convert a vector in this form? That we are going to cover first. So is there any doubt in this topic till now? Representation of vector. So definition is done, exception is done, and the representation part is done, and the magnitude of vector, how do we represent the magnitude of the vector, that part is done. So this is a this I'm writing like this. This is wrong thing. Okay, I should write like this. I should write like this. So this is the vector. This is a vector, f vector, force vector, and this is the magnitude of that vector. This is the magnitude. Got it? So when you put mod, it gives you magnitude of that vector. Always keep one thing in mind. When you are suppose you are writing a force vector, and that force vector has this direction, so you simply write like this. That's F1 is equal to 10 Newton. So you don't have to write F1 is equal to minus 10 Newton or something. When you are drawing a vector, you have given the direction by with the help of arrow. Now you just put the magnitude on that. Sometimes we got confused now, like there is a force vector which is of magnitude 10, but in the negative direction. So you don't write minus 10 over this arrow. Over this arrow you only write the magnitude, and magnitude should be positive. Direction is given by this arrow. So suppose one vector, there is one more force vector in that direction. What will you say? Sir, if this is the positive force, then that will be the negative force. But if the magnitude of that force is also 10 Newton, then you when you are writing mathematically, you might say it is a minus 10 Newton. But when you are representing with the help of arrow, you never write minus 10 on the arrow. So if you are representing a force vector which is in this direction, and you are calling this direction as the positive direction, this direction as the negative direction, then you again write 10 Newton. So this F2 is equal to 10 Newton. You don't write it minus 10 Newton when you, because minus comes because of the direction. So direction, this direction is represented by the arrow. So this is self-understood, like there is a vector of 10 Newton in this negative direction. This is giving that negative direction. But if you are writing force vector without arrow F2, then you will write minus 10 Newton if you have taken this direction as the positive. So when you are not drawing the arrow, then you write F2 as a minus 10. But with the arrow, don't put minus 10 on the arrow. So when you have given the direction, in this direction there is a vector of 10 Newton. So you have drawn an arrow in that direction. Now you just write the magnitude of vector with that arrow. Is this clear to all of you? Sometimes these small things create a huge confusion, and that confusion should not be there, because we will be covering, I will be teaching you the next topics as well, the kinematics, the Newton's laws of motion, and at that time I want all of you to be at least be able to understand these small things. Otherwise some of you will be finding difficulty in understanding the problems. When I'll be writing all these, we will be using all these basic concepts. So I have a different teaching style, different from I try to cover each and every basics to basic information, basic to basic concept of the topic, which can create a slightest confusion in the upcoming chapter, that I'll cover here only. So that's why I ask you, all of you, to completely watch this session till the end. Then you will be master in the vectors. You will be able to answer each and everything you have studied about the vector, or you ever had confusion about the vector. Each and everything you will be able to answer. So the vector representation is clear to all of you. This, how do we represent a vector in this form, this we are going to cover now. So this is the first part. After this, generally people cover the parallelogram law of vector addition, but that is a little bit off track topic. So I am going to cover this part first because this is more interesting. This is easy to handle. So first we will cover this and then we will cover the parallelogram law of vector addition. So there are few points about the vectors, few very important points about the vector that you need to keep in mind. If a vector is shifted parallel to itself, it does not change. If a vector is shifted parallel to itself, it does not change. So suppose there is a force vector. There is a force vector in this direction. If you shift this vector here, it does not change. Do not rotate it. Do not change the length of the vector. If you shift this vector in this direction, it will not change. If you shift this vector in this direction, it will not change. Shift in this direction, not change. Shift in this direction, it will not change. So if this vector is A vector, this vector is B vector, this vector is C vector, they are in the same direction, they all are of same length, then vector A is equal to vector B is equal to vector C. They will not, this will not change. But you don't have to rotate it and don't have to change the length of the vector. If there is a vector in this direction, you shift this vector in this direction, it will not change. You shift this vector in this direction, it will not change. So if a vector is shifted parallel to itself, it does not change. Is this point clear to all of you? If you shift a vector parallel to itself, it does not change. Vector does not change. If a vector is rotated through an angle other than multiple of 2 pi, if a vector is rotated through an angle other than multiple of 2 pi, it changes because the direction is different in this case. So suppose there is a vector and you rotate it by an arbitrary angle in this direction without changing the magnitude. Okay, this is a vector A, this is a vector B, and this vector is rotated by an angle theta. So B vector is not equal to A vector because they both does not have the same direction. But when you rotate a vector by 2 pi, suppose there is this vector in this direction and I rotate this vector with 2 pi. After 2 pi rotation, it again will be in the same direction. So it will be same. But if you rotate a vector through an angle other than, I have said other than multiple of 2 pi, it changes because its direction will be different. So if you rotate a vector by 30 degree, 60 degree, 90 degree, 270 degree, 120 degree, it will change. If you rotate a vector by 360 degree, 720 degree, it will remain same because the direction will remain same and we are not changing the magnitude of the vector. Is this clear to all of you? Yes, direction will be different if you rotate a vector by an angle other than the multiple of the 2 pi, the direction will be different. So these are two important points about the vector. Students, two vectors are said to be equal. Two vectors are said to be equal only if both have the same magnitude. So when you are comparing two vectors, they must have same magnitude, both must have same direction, both must represent the same physical quantity. So when you are comparing two vectors, they both must be in same direction, they both must have same magnitude, and they both must represent the same physical quantity. So you cannot compare force. You cannot say 10 Newton force is equal to 10 meter per second velocity. You cannot say 10 Newton force in north direction is equal to 10 meter per second velocity, which is also a vector, in north direction. This is not true. Okay, this statement is wrong. You cannot say this. 10 Newton force in the north direction is equal to 10 meter per second velocity in the north direction. But you can say this. Magnitude of force is equal to magnitude of velocity. So you can compare their magnitudes, but you cannot say this vector is equal to this vector if they are not the same physical quantity. Is this clear to all of you? Is this clear to all of you? So when we write, we all do the common mistake. We say 10 meter displacement when distance and displacement are same. You have so many times heard this. Distance is equal to displacement. When a particle is moving without changing its direction, then distance is equal to displacement. So here one thing is self-understood, that is we are talking about the magnitude of the displacement. So always remember one thing, when you are comparing two different physical quantities, you can just compare their magnitudes. You cannot compare those vector physical quantities which are different from each other. Okay. Second thing, if you are comparing a vector physical quantity with a scalar physical quantity, you can only compare their magnitudes. This always keep in mind. Okay. So always compare their magnitudes, not the vectors, if the physical quantities are different. And if you are comparing a physical quantity with a scalar physical quantity, then compare their magnitude. So when we are comparing distance with displacement, we are not comparing the distance, which is a scalar, with displacement which is a vector. We are comparing their magnitude. So we are saying the distance is either equal to the magnitude of the displacement. So sometimes we say it or sometimes we just don't say it, but the meaning of displacement is we are comparing the magnitude of the displacement. Is this clear to all of you? Got it? So two vectors, you can only compare two vectors. You can say this vector is equal to this vector if they are same, they represent the same physical quantity, they have the same magnitude, and they represent the same direction. Got it? Let's move to the next point. Okay, this is very basic thing, but sometimes very important to understand. There is one more point. This is also very important. Angle between two vectors means smaller of the two angles between two vectors when they are placed tail to tail or head to head by displacing either of the two vectors parallel to itself. So when we are talking about angle between two vectors, how do we define angle between two vectors? So we suppose there are two vectors, one is like this and the other is like this. Okay, there are two vectors. This vector is the A vector and this vector is the B vector, and we have to talk about the angle between them. So what we do is we place the tail of this vector on the tail of A vector. How do we do that? We can parallelly shift these vectors. This vector does not change. The B vector can be parallelly shifted, it will remain B vector. Or A vector can be parallelly shifted, it will remain A vector. So if I shift this A vector parallel to itself, it will be like this. The A vector will be like this. So you have to keep both the vectors tail to tail. So A vector is parallelly shifted and now both the vectors are kept tail to tail. Then there are two angles. One is this one and the other angle is this one. So this small angle is the angle between both the vectors. Is the angle between both the vectors. Is this clear to all of you? How do we define the angle between two vectors? So mostly angle between two vectors is less than 180 degree. It will be less than 180 degree because we are defining the smaller of the two angles. The other one will be greater than 180 degree. Less than or equal to, it can be equal to 180 degree. So smaller of the two angles is the angle between the two vectors if they are kept tail to tail or head to head. The other way of doing this question is, you can keep both the vectors head to head. You can keep both the vectors head to head. Then also the smaller of the two angles will be, this angle will be, this is B vector, this is A vector, then this angle will be angle between both the vectors. Is this clear to all of you? Is this clear to all of you? Angle between two vectors means the smaller of the two angles between the two vectors when they are placed tail to tail or head to head by displacing either of the two vectors parallel to itself. So this is the definition of the angle between two vectors. Okay, so let's move to the next point, and which is a question. Whatever we have taught, whatever we have studied till now, what are the things we have studied? We talked about the physical quantities, scalar and vector. Then there was an exception, that is the current. Direction has, magnitude it has, but again is scalar. We talked about that as well. We talked about the representation of the vector. Vector is represented by an arrow, head, arrow pointing in the direction of the vector. Magnitude is given by the length of the arrow. Vector can be parallelly shifted, it does not change. We don't have to rotate a vector other than 2 pi, otherwise it will change. Two vectors are said to be equal if they have same magnitude, same direction, represent the same physical quantity. And angle between two vectors means when you place two vectors head to head or tail to tail, the smaller of the two angle is the angle between two vectors. And this we can do by displacing the vectors parallel to itself. Clear to all of you? Okay, so there is first question on the topics which I have covered till now, and that is the three vectors representing sides of an isosceles triangle as shown. Find the angle between A vector and C vector. So there are three vectors A, B, C. You have to find the angle between A vector and C vector. What will be your answer? What will be your answer? What is your answer? What is the angle between A vector and C vector? There are total 18 questions. 18 questions we are going to cover in this vector topic. Don't forget to like the session. If you are enjoying the session, then please like, share among your friends, and subscribe our amazing channel, this wonderful channel where all the faculties are doing very hard work for all the aspirants of NEET 2024. So I can see so many so much variation in the answers. 135, some are saying 135, some are saying 0, some are saying C option. 45 is also one option that is coming out of C option. Many are saying C option. So what is the definition of an angle between the two vectors? So to define angle between two vectors, what we do is we put them tail to tail or head to head, and the smaller angle is called the angle between both the vectors. Okay, this is the definition of the angle between two vectors. So what did I do here is, tail of A is here, tail of C is there. So C vector is like this. I have to put the tail of A with the tail of C. So what I'll do is, I'll shift this vector like this. Parallelly, I'll shift A vector. So by shifting A vector, this is the A vector which is parallelly shifted. This is the C vector which is not shifted. Okay. This angle was given as 45 degree. But this angle will be the angle between both the vector, which will be equal to 180 minus 45 degree. So theta will be equal to 135 degree, and this will be your answer. So angle between A vector and C vector will be 135 degree, not 45. Is this clear to all of you? Now this topic is clear to all of you? So how do we find the angle between two vectors? We place them tail to tail or head to head. Then and only then the smaller of the two angle is the angle between both the vectors. Yes, many of you were correct. Yes, many were of you correct. So this was the question number 1. Now let us talk about triangle law of vector addition. This law is much easier to understand. So there are two laws of vector addition. One is the parallelogram law, other is the triangle law of vector addition. Parallelogram law is a little bit confusing. Students don't find it interesting. They rarely use it. But triangle law of vector addition is much more interesting and very useful in visualizing the vector problems. So what is the triangle law of vector addition? If there are two vectors, a vector and b vector, and we are adding them, we are finding the net of those two vectors. We are finding the resultant of two vectors. Why do we find the resultant? What is the use of the resultant? So let's say on a body, two forces are acting. On a body, there are two forces acting on that body. What will be the effect, net effect of the forces acting on that body? That is called the resultant of those two forces. So in upcoming chapters, there will be certain situations where we will be adding two vectors. So when we add two vectors, we get the net of those two vectors or resultant of those two vectors, or they combinedly giving this vector. We will be replacing those two vectors with a single vector, and that single vector, which is representing both the original vectors, is called the resultant, yeah, net of the two vectors. Okay, so so to find the resultant of vector A and B, there are two vectors A and B, and we are adding them. We are finding the net of those two vectors or resultant of those two vectors. What we do is we place the tail of B on the head of A by shifting parallel to itself, because we are allowed to shift a vector parallelly. It does not change. What we do is, if we are adding vector A and vector B, so we put the tail of B on the head of A by shifting vector B parallel to itself. The resultant vector is a vector joining tail of A to the head of the B. So this will not be clear until I draw few diagrams. So let's say there is a vector A. I am adding this vector into this vector. So suppose two forces are acting on a body, two forces are acting on a particle. Suppose this is a particle. There are two forces acting on this particle, one in this direction, the other in this direction. Okay, these were the two forces, and this force is suppose A vector and this force is B vector. So we can write like them like this also. We have to add these two forces. We have to add these two. We have to find the net of these two forces. So what we will do is, we will parallelly shift this vector and place the tail of vector V on the head of vector A. What we will do is, we will place the tail of vector V on the head of vector A like this. So this is vector A and this is vector V. So what will be the resultant or net of these two vectors? A vector from tail of A to head of B will be the resultant of these two vectors. So we represent the resultant with R vector, or we can represent this with A vector plus ka B vector. So what will be the magnitude of resultant? The length of this line, this arrow, will be the resultant. What is the magnitude of A? This length. What is the magnitude of B? This length. What is the magnitude of resultant? This length. So this is written here. To find the resultant of two vectors A and B, we place the tail of B on the head of A. We place the tail of B on the head of A by shifting it parallel to itself. Then the resultant is a vector joining from tail of A to the head of B. So this way we can find the resultant of A vector and B vector. This way we can find the resultant of A vector and B vector. Got it? Sir, in the last question I got the answer 135, but I got confused that 45 is smaller than 35, then why don't? So basically in the last question, first we have to place two vectors tail to tail. Then there are only two angles, this one and this one. This is not the angle. There is no vector. I drew this line. So this angle, there are these two angles. Not 45 is not the angle here. Okay? So there should not be confusion. Is that clear to all of you? There was a confusion, like now it is clear to you. So this is the vector A plus ka vector B. Got it? So this is the triangle law of vector addition. There are certain properties of the triangle. There are certain properties of the triangle. Sum of two sides of triangle is always greater than or equal to third side. Always keep this thing in mind. So sum of two sides of the triangle is always greater than or equal to third side. So resultant wala is the third side, A and B are the two side. So when we directly add their magnitude, I am not adding vectors. If I write like this, A vector magnitude means this length, B vector magnitude means this length. This must be greater than or equal to A vector plus B vector, which is the resultant vector magnitude. So resultant vector is always less than or equal to sum of magnitudes of both the vectors. So suppose their vector magnitude of A vector is 3, magnitude of B vector is 4, then their resultant can never be greater than 7. Then their resultant can never be greater than 7. Is this clear to all of you? So this is the property of the triangle. The resultant A and B, resultant vector, A vector and B vector are forming a triangle. So there is a property of the triangle. This length plus this length must be greater than or equal to third length, greater than or equal to. So you can say the resultant length of the resultant must be less than or equal to sum of the magnitude of A and magnitude of B. Is that point clear to all of you? Is that clear to all of you? When you are adding two vectors, their resultant will be always less than or equal to the sum of the magnitudes of the vector. I am saying sum of the magnitudes of the vectors. When they are equal, if theta is equal to 0 degree, angle between A and B is 0 degree, they both are in the same direction, then A plus B is equal to mod of A vector plus B vector. So resultant, magnitude of resultant is equal to A plus B. I am not writing arrow on A and B. Okay. Now these are the magnitude. So magnitude of the resultant will be equal to sum of magnitude of A and B. So let's say A vector is of magnitude 3 Newton, B vector of magnitude 4 Newton. They are in the same direction, then their resultant will be 7 Newton. Got it? Clear? When two vectors are in the same direction, A vector and B vector, they are in the same direction, then their resultant is from tail of this to head of this. So this is the resultant. So this is A vector, this is B vector, then this is the R vector. Theta is 0. So when theta is 0, when angle between both two vectors is 0, the resultant is equal to, simply add the magnitudes of both the vectors. Otherwise, the resultant will always be less than the sum of the magnitude of the two vector. Is that clear to all of you? That clear? There is one more property of the triangle, and what is that? Difference of two sides must always be greater than or equal to third side. Sorry, difference of two sides must always be less than or equal to third side difference. So resultant of two vectors, which is R, must be less than or equal to A plus B, and this must be greater than or equal to A minus B. Okay. So resultant must lie between this range. So there are, if they we put mod here sometimes, because we are comparing the magnitude only. Sometimes A is less than B, then it will be negative. We have to compare the magnitudes. So if there are two vectors, 3 Newton and 5 Newton, their resultant maximum can be 3 plus 5, 8 Newton, and their difference or minimum value of the resultant can be 2 Newton when you are doing 5 minus 3. Okay, so resultant lie between this range. So this is something which we need to keep in mind. So value of R is maximum equal to A plus B. I am not writing arrows. These are magnitudes when theta is equal to 0 degree, and value of R is minimum, which is equal to A minus B or mod when theta is 180 degree. So when angle between two vectors is 180 degree, suppose there is this vector A vector, B vector is opposite to this, so we put B vector like this. This is B vector, this is A vector, then the resultant is this vector. So resultant will be A minus ka B. So minimum will be, we get the minimum resultant when both vectors are opposite to each other. We get the maximum resultant when both vectors are acting in the same direction, and the resultant always lies between these two values, A plus B, A minus B and A plus B. Between lies these two values. Got it? Clear to all of you? So this is the triangle law of vector addition. Triangle law of vector addition. We will solve some numerical also on this. There is a very important point about this. When three or more vectors are forming a closed loop, by placing them head to tail in a order, then their resultant is 0. Suppose I have to add three vectors, A vector, B vector and C vector. So students, this is the A plus B vector. If I say this is a A vector, this is a B vector, then this will be A vector plus B vector. Triangle of vector addition. If I have to add A vector plus ka B vector plus ka C vector, I have to add C vector also. And now we are finding the resultant. So let's say suppose C vector is in this direction. C vector is in this direction. What we will do? We will say we have to add C vector into A plus B. So A plus B vector we have already. What we will do is, we have A vector, we have V vector, and we put C vector here, because this is the A plus B vector and we are adding C vector, then this is the A plus B plus C vector. This is A vector, this is B vector. So this is A vector plus B vector, and we put the tail of the C vector on the vector A plus B vector, then we get the A vector plus ka B vector plus ka C vector. So this will be the resultant of all these three vectors. This is the, so this law is very important, because with the help of this law we can directly talk about the more than two vectors. In parallelogram law of vector addition, there is a limitation of two vectors we can add at a time, but triangle law of vector addition can deal with multiple vectors at a time. So whenever there are Whenever there are more than two vectors, we can directly place them one by head to tail, and the tail of first and head of last will be the resultant vector. So to find the resultant of two vectors A and B, we place the tail of B on the head of A by shifting it parallel to itself. Then the resultant vector is a vector from A to tail of A to head of B. So when there are three vectors, A vector, B vector and C vector, what we will do? We will place the tail of B vector on the head of A vector. We will place the tail of B vector on the head of A vector, tail of C vector on the head of B vector, and the vector joining the tail of A and the head of C will be the resultant vector. Clear? Clear to all of you? So when we have three vectors, I am repeating it again, okay? When we have three vectors, A vector, B vector and C vector, we have to find the resultant of these three vectors. What we will do is, we will place the tail of B on the head of A and the tail of C on the head of B. So there will be A vector, B vector and C vector. So head of C is there, tail of A is here. When we are adding these three vectors, we are finding the resultant of these three. So what is the resultant? Resultant is simply a vector from the tail of A to the head of C. So this vector is the resultant vector of A, B and C. So A vector plus B vector plus C vector is a vector joining the tail of A to head of C if A, B, C are placed head to tail, head to tail, head to tail in a order. So when three or more vectors are forming a closed loop, so suppose there are three vectors and they are forming a closed loop. There is this vector, there is this vector and there is this vector. They are forming a closed loop. This is A vector, this is B vector and this is C vector. Tail of B is on the head of A, tail of C is on the head of B and head of C is here. So what will be the resultant of A plus B plus C? What will be the resultant? So resultant of this is a vector from the tail of A to head of C, but head of C is on the tail of A only. So there will be a vector of zero magnitude. That vector is called the null vector. That vector is called the null vector. Why do we define null vector? Why don't we directly call it 0? Because on the left hand side you are adding three vectors and the resultant of those three vectors must be equal to a vector. We must be comparing them with a vector, but the magnitude of that vector is 0. That's why we call it a null vector. Again, we are calling it vector only. The magnitude is 0. That's why we are calling it null vector. Okay. A vector plus B vector plus C vector is equal to null vector. This is called the null vector. So when three or more vectors are forming a closed loop, by placing them head to tail in order, then their resultant is 0. So on the head of A, tail of B is there, on the head of B, tail of C is there, and they are forming a closed loop. So the resultant of these three vectors will be 0. Similarly, if there is a vector A, vector B, there is a vector B, vector C and vector D, they are forming a closed loop again. This is a vector A, this is vector B, this is vector C and this is vector D. They are forming the closed loop. So the resultant of these four vectors will also be equal to 0. A plus B plus C plus D must be equal to 0. Okay. So whenever there are vectors forming a closed loop, while placing them head to tail, the resultant must be equal to 0. Always keep one more thing in mind. If there are three vectors or four vectors and you are saying their resultant is 0, if you are dealing with the three vectors and the four vectors and you are saying their resultant is 0, then they must form a closed loop. And always remember this, out of those three or four vectors, out of those 3 or 4 vectors, the maximum magnitude vector, the magnitude of the vector, the maximum magnitude of a vector must be less than or equal to sum of the remaining magnitudes of the vector, and then only they can form a closed loop. So listen, suppose I am saying there are vectors 1 Newton, 2 Newton, 3 Newton and 8 Newton, and I am saying they will be forming a closed loop. Is it possible that force of 1 Newton, 2 Newton, 3 Newton and 8 Newton can form a closed loop? Never. They can never form a closed loop. Why? This 8 Newton vector will be the largest of magnitude 8 unit. Okay, we have to keep this vector, the tail of this vector, on the head of this. Even if I do like this 3 Newton, 2 Newton and 1 Newton, the resultant will never be equal to 0. This will be the resultant vector. So if there are 3 or 4 vectors and we want their resultant to be 0, the maximum magnitude vector should be the vector with the maximum magnitude. The magnitude of that vector should be less than or equal to sum of the remaining vectors. Otherwise, it will never be able to form a closed loop and the resultant can never be 0. And this is a very, very important point in the vector. Got this point? So to form a closed loop, or you can say one thing, even if it is a triangle or quadrilateral or some other shape, the biggest side, the length of the biggest side is always less than or equal to length of the remaining sides. Is this clear to all of you? Even in triangle or any shape, this is a closed shape, the length of the biggest side is always less than or equal to sum of the lengths of the remaining sides. This is always true. Okay, so any set of vectors can only form a closed loop if the biggest side length is less than or equal to sum of the lengths of the remaining sides. Then and only then it can form a closed loop, and then only the resultant can be 0. So while dealing with the vectors, more than 3 vectors, more than 4 vectors, always keep this in mind. If you are making the resultant of these vectors equal to 0, then the maximum magnitude side, the magnitude of the maximum magnitude vector must be less than the sum of the other vectors. Clear? Okay. So these are few points. So there is question number 2. Find the minimum number of non-coplanar vectors which has 0 resultant. What is the minimum number of non-coplanar vectors which has 0 magnitude, 0 resultant? What is the number? You tell me. Out of these 4 values, which value which is the minimum number of the non-coplanar vector which has the 0 resultant? So non-coplanar vector means they do not lie in a plane. Okay, so suppose I say these 2 vectors are coplanar, then this vector is also coplanar, this is coplanar, this is coplanar, all the vectors in this plane are coplanar, but this vector is not coplanar to these 2 vectors because these 2 vectors are in this plane and this is out of this plane. So how many minimum number of non-coplanar vectors are required such that their resultant is 0? What is the number of non-coplanar vector which has 0 resultant? You all are very good at vectors. So let's talk about first A option, 2. So 2 vectors with 0 magnitude, they both must be opposite to each other. So The magnitude, suppose 2 unit, then the magnitude of this also 2 unit, and they are opposite to each other, their resultant will be 0. So they are the planar vector. Okay, 2 vectors will be planar. Suppose there are 3 vectors, let's say 3. So 3 vectors, their resultant is 0, then they must form a triangle. Then only then their resultant will be 0. A vector plus B vector plus C vector. And triangle is a planar shape. Triangle will always lie in a plane. Triangle will always lie in a plane. So when 3 vectors you take, they will and their resultant is 0, they will always form a triangle. And triangle is a planar shape. So this cannot be the case. So minimum number of, let's talk about 4 vector. Suppose there is one vector in this plane, there is another vector in this plane. Okay. Now the third vector can be like this. Third vector is like this. It is not in the plane. Okay. And fourth vector like this. It will form a closed loop. But it is not a planar shape. So third vector is not in this plane. Fourth vector is not in this plane. But their resultant is 0. They are forming a closed loop. So minimum number of non-coplanar vectors. Minimum number of non-coplanar vector is 4. This is the minimum number. Minimum number of non-coplanar vector whose resultant is 0 is 4. Clear? Okay. Question number 3. Third question. The vector sum of the forces of 10 Newton and 6 Newton can be. Out of these 4 options, you have to answer. The vector sum of the forces of 10 Newton and 6 Newton can be. What is the vector sum? What is the possible vector sum of the 10 Newton and 6 Newton force? What is the possible vector sum of the 10 Newton and the 6 Newton force? Anyone? What can be the possible value of their resultant of the 10 Newton and the 6 Newton out of these 4 values? What can be the possible value of? Please don't forget to like the session. Please don't forget to like the session. So the vector sum of the forces of 10 Newton and 6 Newton can be. So the minimum value is when they are placed opposite to each other. That is 10 minus 6, which is the 4 Newton. And the maximum value of resultant will be 10 plus ka 6 when they both are in the same direction. 16 Newton. So resultant will lie between 16 Newton and the 4 Newton. So 4 to 16 Newton, all the values are possible. Resultant by varying the angle theta between the vectors. So which value lie between this range? That is this one, 8 Newton. 8 Newton can be the resultant of the 10 Newton and 6 Newton. 18 cannot be the resultant of these two. 20 cannot be, and 2 cannot be the resultant of 10 Newton and 6 Newton. Clear? Clear? So this was the question number 3. Question number 4. Which of the following force cannot be a resultant of 5 Newton and the 7 Newton? Which of the following forces cannot be a resultant of 5 Newton force and the 7 Newton force? Which of the following cannot be? We have to find cannot be the resultant. Out of these 4 options, which cannot be the resultant of these 2 forces? Obviously, so minimum value of R will be here, 7 minus 5 equal to 2. Maximum value of R is 7 plus 5, which is 12. So 2 is possible, 10 is possible, 5 is possible, 14 is not possible. It can never go beyond 12 and 2. 2 can be possible value, 12 can be the possible value. Between 2 to 12, it can be any value based on the angle between both. 14 can never be the resultant of 5 Newton and the 7 Newton force. Clear? Okay. Let's move to the question number 5. Back to back questions. 3 forces are acting on a body. In which of the following options can the body be in equilibrium? So, for a body to be in equilibrium, for a body to be in equilibrium, the net force on body should be equal to 0. So we have to find which set of the forces can be equal to 0. The resultant of which set of the forces can be equal to 0. So 3 forces are acting, like in first set 1, 4, 7, 2, 3, 8, 3, 3, 7, 2, 4, 5. Which set of the force can have a 0 net force on the body? The resultant of which set of the force can be 0? This is the question. Tell me the answer of this question. Did you ever solve a sheet on the vectors? Are these questions you find the relevant one? Like, are these questions helpful? The concepts I am covering, are they helpful for all of you? Because I want to cover the topics or the concepts which are directly related to your content you are solving. Like even in the plus classes or in the on the YouTube, once I am done with a chapter, I am done with a topic, you must not find difficulty while solving any institute material. Like, you must be able to solve any material, any institute material. It should not matter which institute material you are solving, you should be able to solve that. This I try to cover the concept this way so that you don't find difficulty in any institute material. And once I am done with this chapter, you will be able to solve, you can attempt the material of any institute you have. You won't face difficulty in the vectors, neither in the definition part, theory part, nor in the practice part. Did you solve it? So there is a first pair is 1 Newton, 4 Newton and 7 Newton. Even if I place 1 Newton and 4 Newton in one direction, 7 Newton cannot be compensated. This can never form a closed loop. No. Or you can say, when I put 2 Newton and 3 Newton in one direction, 8 Newton cannot be cancelled out. The resultant of 2 Newton and 3 Newton. So if I am drawing a triangle of 2 unit side length, 3 unit side length, 8 unit side length, property of triangle is the sum the third side should always be less than or equal to sum of the remaining 2 sides. So if I consider third side as 8 Newton, it is greater than the sum of the 2 remaining sides, 2 Newton and 3 Newton. So it cannot be the pair which has 0 resultant. Okay. 3, 3, 7, the sum of the third side is greater than the sum of the remaining 2 sides. It cannot be the case. 2, 4, 6, yes, this is possible. So 2 Newton, 4 Newton on this in this direction, 4 Newton, and 5 Newton in this direction. This can be the answer. 2 Newton, 4 Newton and the 5 Newton. So third side is less than the sum of the remaining two sides, it can form the triangle. Remaining cannot form the triangle, and if they cannot form the triangle, their resultant cannot be equal to 0. Clear? So sum of three vectors to be equal to 0, they must obey the property of the triangle, and that is the third side length must be less than or equal to sum of the remaining two sides. So out of if you pick any set, the biggest magnitude of the force, the largest magnitude of the force must be less than or equal to sum of the remaining two. Then and only then they can form a triangle, and then their resultant can be equal to 0. So this was the question number 5. So all these questions are on the vector sum of the resultant of the two vectors. So we have covered 5 questions till now. Now we are going to talk about the unit vectors. Okay. We are going to talk about the unit vectors. What is a unit vector? A vector of unit magnitude. Obviously, we are talking about the unit vector, then its magnitude must be equal to 1 unit. A vector of unit magnitude in a particular direction is called a unit vector. Unit vector is a dimensionless quantity. This is very important. Sometimes they directly ask this. The unit vector does not have any dimension. Okay. So let's say there is a vector in this direction. There is a vector A vector. Okay. So this is a A vector. So this vector has some magnitude. Let's say this has magnitude equal to 5 unit. We want to draw a vector, unit vector in this direction. And that vector is of unit magnitude, and it is written like this, A cap. So A cap is a unit vector, unit magnitude, a vector in the direction of A vector. Okay. So A cap vector is a unit magnitude vector in the direction of the A vector. This way we define the unit vector. So unit vector is defined like this. A vector is divided by magnitude of A vector. We get unit vector. So A vector has some magnitude, and we divide that A vector with a magnitude of A vector, we get the unit vector. So unit vector is defined like this. This is the definition of the unit vector. So unit vector are dimensionless. Why they are dimensionless? Because this A vector has dimension, and the magnitude of A vector also has dimension. We are dividing the same physical quantity with the same physical quantity. So the unit gets cancelled out. So the unit vector is a dimensionless. Okay. So unit vector will be dimensionless. So a vector of unit magnitude in a particular direction is called a unit vector. Unit vector is a dimensionless physical quantity. There is a very important point. There are two important points. These are very important. So I forgot to add those in the notes. If a vector is multiplied by a positive scalar lambda, its magnitude becomes lambda times, and direction remains same. This is a very important point about the vector. Second point is, if multiplied by minus lambda, negative lambda, then magnitude becomes lambda times and direction get reversed, and direction gets reversed. So if you multiply a vector with a negative number, the magnitude of that vector is multiplied by that number and the direction is reversed. So here what we are doing, we are basically multiplying a vector with 1 upon magnitude of a vector. So the magnitude of a vector becomes 1 upon a times, let's say the magnitude of a vector is 10 unit. So we are multiplying this vector with 1 upon 10. So what will happen? The magnitude and the resultant vector we get of 1 by 10 magnitude. So a vector has 10 magnitude and its magnitude becomes 1 by 10. So we get a vector of unit magnitude. So that's why this vector is called the unit vector. Okay. So these are the two important points. If we multiply a cap with 2, if I multiply a cap with 2, so it becomes 2a cap. So it is a vector of 2 times magnitude of this vector in the same direction. If I multiply this, see, unit vector is also a vector. Unit vector is also a vector. And if I multiply unit vector with 2, I get a new vector of 2 times magnitude of the unit vector in the same direction. This is a different vector from this vector. If I have knowledge of unit vector, I can get any vector of any magnitude in that direction of the unit vector. So suppose I need a vector of 10 magnitude in this direction. I'll simply multiply this a cap with 10. If I multiply a cap with -3, then I will get this vector -3a cap. The direction of this vector will get reversed. So -3a cap will look like this. The direction will be reversed and the magnitude will be 3 times, but the direction of -3a cap and a cap will be opposite to each other. So if a cap is multiplied by -3, its direction will get reversed and the magnitude will be 3 times of this vector. And what is the magnitude of this vector? 1 unit. The magnitude of this vector will be 3 times of that vector. Is this clear to all of you? Is this clear to all of you? These are two very important points. These 2 points are very important. If we multiply a vector with a positive number scalar, positive lambda, then its magnitude becomes lambda times and the direction remains same. If we multiply by minus lambda, then magnitude becomes lambda times and the direction gets reversed. So if you have knowledge of unit vector, you multiply that unit vector with any number, you will get a vector of that times magnitude in the direction of same unit vector. If you multiply that vector with a negative number, you get another vector of that time the number you have multiplied times magnitude in the opposite direction. Clear? This thing is going to help us in understanding the vector which are represented like I cap, j cap and k cap. So what are components of the vector along the x-axis and y-axis and the z-axis? See, we have defined I cap. I cap is already defined. It is a unit vector. It is a unit vector in the direction. It is a unit vector in the direction. It is a unit vector in the direction of positive x-axis. Positive x-axis. A unit vector in the direction of positive x-axis is called the I cap. J cap. Unit vector. It is a unit vector in the direction. Unit vector in the direction of positive y-axis. And k cap. Unit vector in the direction of positive z-axis. Is this clear to all of you? So if I draw x, y and z axis, if I draw x axis in this direction, y axis in this direction, z axis like this. So this is x, this is y, and this is z. So I cap is a vector of unit magnitude. So I cap is a vector of unit magnitude in this positive x direction. Okay. J cap is a vector of unit magnitude in positive y direction. K cap is a vector of unit magnitude in z direction. So this is a I cap. This is a j cap. This is a k cap. This point is 1, 0, 0. This point is 0, 1, 0. This point is 0, 0, 1. So a vector from 0, 0, 0 to 1, 0, 0 will be a unit vector in the direction of x-axis, which is called the I cap. So what is I cap? A vector of unit length in the positive x direction. What will be minus I cap? A vector of unit length in the negative direction, negative x direction. What will be j cap? J cap is a vector in the positive y direction of unit magnitude. K cap is a vector in the positive z direction of unit magnitude. I cap, j cap and k cap, these are the three unit vectors along the x, y and z direction. If I draw a vector from 2, 0, 0 to 3, 0, 0, 2, 0, 0 to 3, 0, 0, what will be the length of this vector? Again the length will be 1 unit, because x equal to 2 to x equal to 3, 1 unit. This is also called as I cap. So any vector in this direction of 1 magnitude is called the unit vector or I cap. Got it? Got it? Is this clear to all of you? So how do we form a vector of 3 I cap, 4 plus 4 j cap and so on? So we are moving towards that only. So let's say this is the x-axis and y-axis in this direction. So this is x-axis, this is y-axis. Okay. This is called 0, 0. I want to draw a vector. Suppose this point is A. This is 3, 0, 3, 0. Z axis we are not taking right now. So what will be this vector? Suppose I want to draw a vector like this in the positive x direction from 0, 0, 0 to 3, 0. What is the magnitude of this vector? What is the magnitude of that vector? What is the magnitude of OA vector? Can anyone tell me the magnitude of OA vector? What is the magnitude of OA vector? What is the magnitude of OA vector? Magnitude is 3 unit, because x equal to 0 to x equal to 3. What is the magnitude of OA vector? 3 unit. And what is the direction of OA vector? Positive x axis. So what will be this OA vector? 3 I cap. So OA vector is 3 I cap. So OA vector is 3 I cap. Let's say I take a point here 0, 4. This point is B, and I want to draw a vector from O to B, and this is called the OB vector. This is OA vector. O से A की तरफ OA vector. This is OB vector. What is the magnitude of this vector? What is the magnitude of OB vector? You'll say 4. What is the direction of OB vector? You'll say, sir, plus ka y direction. And do you have any vector in this direction, unit vector? Yes, that is j cap. If a vector of 4 times magnitude of j cap will be 4 j cap. See, unit vector in this direction is j cap. I want a vector of 4 times magnitude of the unit vector and in the same direction. What will I do? I'll simply multiply j cap with 4. So I get 4j cap. So this OB vector is 4j cap. Now you tell me, if there is a point here and the coordinate of this point are 3, 4, and I want to draw a vector. I want to draw this vector. This point is C. What will be OC vector? How can I write OC vector? Is there a way to write OC vector? Is there a way to write OC vector? So what I want you to do is, can I shift this OB vector parallel to itself? You'll say, yes, sir, you have taught us this in the beginning only. So what will be this vector? This vector will be OB vector only. OB vector is parallelly shifted only, okay? Can you apply the triangle law of vector addition on the head of this vector? Tail of this vector is kept. And from the tail of this to head of that vector is joined. So OC vector will be equal to OA vector plus ka OB vector, which will be equal to 3i cap plus ka 4j cap. Are you able to understand how do we form a vector in I cap, j cap and k cap format? How do we represent a vector in I cap, j cap and k cap format? This is the way we represent a vector. What is the meaning of this? So this OA vector and OB vector are rectangular components of OC vector along x and y axis. So these are called the component of OC vector. This OA vector and OB vector components are also vectors. So if a vector can be broken into two component, that means the vector is the resultant of those two vectors. So the OC vector is the resultant of OA vector and OB vectors. OA vector and OB vector are the component of the OC vector. OA vector and OB vector are the component of the OC vector. What will be the magnitude of OC vector? What will be the magnitude of OC vector? So 3 square plus 4 square is equal to 5. You remember this is 4. Do you remember this angle is 53 degree? So component of OC vector along x-axis will be 5 cos 53. Component of OC vector along y-axis will be 5 sin 53. 5 sin 53 4, 5 cos 53 3. You get the component of the OC vector along the x-axis and the y-axis, and this is the way we represent a vector. So when I say there is a vector I cap plus j cap plus k cap, what is the meaning of that vector? It is a vector which has x component equal to 1, y component 1 and z component 1. It is the resultant of these three vectors, is a vector I cap, j cap and k cap. Clear? Is this clear to all of you? So can I parallelly shift these vectors? Let's say I want to draw this vector. This vector. So this point, this is x-axis, this is y-axis. This point is x1 comma y1. This point is x2 comma y2. Can I draw this vector? This AB vector. Let's call it AB vector. Can we write this vector? So what you have to do is, you simply draw this line parallel to x-axis. Draw a line perpendicular to, or the parallel to y-axis. The length of this line is x2 minus x1. The length of this line is y2 minus y1. So this vector is basically, this vector is equal to sum of this vector, sum of this vector. This vector is along x-axis. So AB vector is equal to x2 minus x1 I cap, y2 minus y1 j cap. So this way we can write a vector joining A, which has a coordinate x1 and y1, to the point B, x2 comma y2. So if any vector is given like, suppose a vector P is given like x I cap plus y j cap plus z k cap. So magnitude of vector P, magnitude of P vector will be equal to mod P, and this is given by x square plus y square plus z square. So magnitude of any vector is given like this. This way we represent the vectors. This is called the x component of the P vector. This is called the y component of the P vector. This is called the z component of the P vector. Component part is clear to all of you? Is component part is clear to all of you or not? There's a very important concept. So unit vector, how do we find unit vector? And component part is again a little, we have to talk about the component. So component of a vector, we're going to talk about component of a vectors. Then we will solve some numerical on it. So let's say there is a one direction is this and the other direction is this. There is a vector in this direction. Suppose this vector is P vector. This angle is given as theta. This is x-axis, this is y-axis. So component of P along x-axis is, so when you are doing component of P along x-axis and this angle theta is given, then this component will be P cos theta. And component of P along y-axis will be P sin theta. So whenever angle is given with a particular direction, in that direction the component will be cos theta of that vector, and the other direction it will be sin theta of the vector. So this component will be P cos theta, this component will be P sin theta, this will be P cos theta, this will be P sin theta. This way we do the component of the two vectors. Okay, is this clear to all of you? Now there is a one more concept remaining, that is the, I almost forgot this concept, na? Like I could have missed this concept, but as you know, I don't leave a concept. So unit vector concept, unit vector along a vector which is given as x I cap plus y j cap plus z k cap. If a vector is given in this format, I cap, j cap and k cap, and you have to find the unit vector in that direction, what you do is a cap is equal to x I cap plus y j cap plus z k cap divided by magnitude of A, which is x square plus y square plus z square. This is the unit vector in this direction. Okay, this way we write the unit vector in along a vector which is given in the format of I cap, j cap and k cap. All the concept clear to you? How do we write I cap, j cap, k cap format? How do we represent a vector in this format? Why do we do that? What is the meaning of 3 I cap, 4 j cap? So basically the meaning of 3 I cap, 4 j cap is 3 is the component in the positive x direction, 4 is the component in the positive y direction, 5 is the component in the positive z direction. ठीक है, unit vector is done, magnitude is done, component of a vector is done. So let's solve some numerical on it. A man is moving with a 10 meter per second along the line 37 degree north of east. Then write the component of the velocity along the east and north direction. So a man is moving with the 10 meter per second along the line 37 degree north of east. Okay. You have to write the component of the velocity along the east and the north direction. So velocity is in what direction? Northeast direction. Not in northeast direction. 37 degree north of east. Write the component of the velocity along the east and north direction. Write the component of the velocity in the north and east direction. Which option is the correct option? Done? So C option, B option, I can see options in the chat box. C, B. ABCD. Wow, very good. So let's say let's take north and east in these two directions, okay? East and north. This person is moving with velocity 10 meter per second, 37 degree north of east. North of east. It is going like this. This velocity is 10 meter per second. This angle is 37 degree. North of east. North of east. East के north में. ठीक है? 37 degree. What will be the component of this? The component of this will be this component in east direction and this component in the north direction will be 10 cos 37, which is 8, and 10 sin 37 is equal to 6. So velocity along the east and north, east component will be 8 and north component will be 6, and this will be the answer. Second will be the correct option. Second option will be the correct option. B option is the correct option. You all were saying third and fourth. Most of you were telling the third and fourth. B. Nobody said B option will be the correct option. Clear? Clear to all of you? Question number 6. Let's talk about question number 7. This is going to check your understanding of this topic till now. There is a question number 7. The rectangular component of a vector r 2, 2, the corresponding rectangular component of another vector r 1, √3. Find the angle between the two vectors. So there are two vectors. One has component 2, 2, the other has component 1, √3. What will be the angle between both the vectors? What will be the angle between both the vectors? Question number 7 is there. Question number 7 is there. How do we know the value of sin 37? That I covered in the previous lecture. See, each and everything I cover in the lectures. When I say I have taught you the mathematical tool, complete mathematical tool chapter, then you must be able to answer this kind of questions. So value of sine 37, cos 37 we already covered in the previous lecture. Please go through that lecture. What will be the answer of this question? Can anyone tell me the answer of this question? So the answer of this question will be, there are two vectors, one which has two components and other this is x, this is y, this is x, this is y. One has a component 2, 2. So 2 will be in this direction and 2 in this direction. 2, 2. This vector will be like this. What will be this angle? 45 degree. Okay, this is 2 unit. This is 2 unit. So resultant of these two vector will bisect this angle. This is first vectors. Let's call it a vector. The other vector is 1 is this component and root 3 is this component. So this vector is in this direction. So what will be this angle? Let's call it alpha. Tan alpha is equal to root 3 divided by 1. Alpha comes out to be 60 degree. This angle will be 60 degree. This vector is B vector. So B vector has angle 60 degree with x-axis. A vector has angle 45 degree with x-axis. So when I draw both on the same axis system, now I get this is the A vector and this is the B vector. This has angle 45 degree. This has angle 60 degree. So this angle will be 15 degree between A vector and B vector. So angle between A vector and B vector will be 15 degree and A option will be the correct option. 15 degree will be the correct option. Is this clear to all of you? If you are able to solve this question, this is the, like, you can treat the most difficult question on the component part is this one. If you are able to understand this concept, that means you are done with the component part of the vectors. Done? Okay, so component part is done. Addition and subtraction of the vectors. So we are already doing the addition part. We have already studied the triangle law of vector addition. But now we have studied vectors in form of I cap, j cap and k cap. Let's call it, suppose there is a vector, A vector, which is x1 I cap, x2 y1 j cap, z1 k cap, B vector x2 I cap, y2 j cap, z2 k caps. Let's suppose we have these two vectors. We want to add both the vectors, A vector plus B vector. What we will do? We will add I cap and I cap. It becomes x1 plus x2 and this is plus I cap. y1 plus y2. This is this j cap. z1 plus z2. This is very easy to deal with. This is this k cap. So what you have to do? You have to directly add the x component, x component of A vector and with the x component of B vector, y component with y component, z component with z component. When you are doing A vector minus B vector, x1 minus x2 I cap, y1 minus y2 j cap, z1 minus z2 k cap. This is very easy to deal with. When you are doing addition or subtraction of these kind of this form of the vector, this is very easy to deal with. So most of the time when we are finding the resultant of the two vectors, what we will do? We will convert those vectors in the form of I cap, j cap and k cap, and then we will do the addition part. Then we will do the subtraction part. That will be the super easy method to solve a resultant problem. Got it? So this was the concept. So there is a question on that concept only. Find the resultant of a force P of magnitude. There is a force which is the P vector, and it has a magnitude 10 Newton in the direction 37 degree north of east, and a force of Q of 2 Newton. So there is a Q force of 2 Newton along the north direction. What will be the resultant of these two vectors? How do we find the resultant of these two vectors? We have not studied the parallelogram law of vector addition till now. Students, there will be special class tomorrow at 2 p.m. In that special class, I am going to teach. I am going to make you practice more questions on the vectors. So do not forget to attend the special class. Let me ask them to add the special class link. So they will pin the link in the chat. So at 2 p.m. there will be this special class, and this is in this special class. So this is more of a theory class, and we are doing the illustrations. And you need to do practice of the vector questions. For that, don't forget to join the special class tomorrow at 2 p.m. What is the answer of this question? Okay. So how do we solve this question? There is a one method is triangle law of vector addition, parallelogram law of vector addition. What can we do is we just draw x and y directions. This method is super easy method. Okay, what is the method? Let's call east as x-axis, north as y-axis. So there is a force at 37 degree north of east of magnitude 10 Newton. There is this force of 10 Newton, and this angle is 37 degree. There is one more force of 2 Newton in the north direction. Okay, so there are these two forces. We have to add them. What we will do? We can write the component of the 10 Newton force in the x direction and the y direction. What we will do is we'll write the component of this 10 Newton force in x and y direction. So component of 10 Newton in this direction will be 10 cos 37. Cos 37 is 4 by 5. It will be 8 Newton. 10 sin 37. It will be 6 Newton. So first force is like F1 is equal to 8 I cap plus 6 J cap. And the second force is already in the north direction only, of magnitude 2 Newton, so 2 J cap. So resultant is F1 plus F2. Directly add. There is no I cap, so 8 I cap plus 6 plus 2, 8 J cap. So resultant has 8 component along x-axis and 8 component along the y-axis. So net will be equal to root over 8 square plus 8 square, which is equal to 8 root 2. And this is the resultant at an angle of 45 degree with the north and east both the direction. So it will be northeast direction. 8 root 2 Newton will be the resultant of this force. Or you can directly say, sir, in this direction there is 2 Newton and 6 Newton. So the resultant in this direction will be 8 Newton and this direction 8 Newton. So resultant will have two component, 8 Newton and 8 Newton. So resultant will be 8 root 2 in the northeast direction. Clear to all of you? So in Newton's laws of motion, we will solve so many questions like this, and this is the base of the Newton's laws of motion, where resultant of the forces is we are asked to find. There is one more question, bachcho. Please try to solve this question to check your knowledge of or your understanding of this topic, vector. So 4 forces are acting on a particle are given as shown. There are 4 forces acting on this particle. Find the resultant force on the particle and its direction with F1 vector. What you have to do is you have to find the resultant of all these forces and its direction with the F1 force. So 4 forces, what are the 4 forces? 4 Newton in this direction, 5 Newton at 53 degree angle, 10 Newton at 37 degree angle with this line, and you have to find the resultant of all these forces. Can you recall this kind of questions you have already solved in the Newton's laws of motion? You solved so many questions with the block and a string of this kind. There are multiple string connected to a block and that block is in equilibrium. This kind of question we are solving. So how do we solve this kind of question? That I am going to teach you. So find the resultant of all these 4 forces and its direction with respect to F1. NLM before I'll be teaching Cartesian thermodynamics on 27th of December. Next month I'll be teaching kinematics. On the first week of the January, I'll be teaching kinematics. And then Newton's laws of motion and friction. And in between I will be teaching calorimetry, heat transfer and thermal expansion. So one topic from starting and one topic from the end of the class 11th I'll be covering. One from the beginning and one from the last. This way we will go. Parallelly we will cover 2 topics. One from the end, one from the beginning of the class 11 syllabus. I'm trying my best to cover like at a maximum pace all the topics of the physics, like in the minimum time. The thing is, ultimately like I'll cover kinematics in only one lecture, NLM in one lecture, friction in one lecture. That way I'm saving your time as well as mine, and more number of chapters will be covered, and I am covering in very detail, in depth knowledge. Nothing I'm leaving behind which is important in for your exam. Each and every concept I am covering. You can see this kind of question, whatever the possibility of the question that can be asked on the from this part, vectors. Those all the possible concept we will cover during these classes. 4 forces acting on a particle are given as shown. Find the resultant force on the particle and its direction with F1. Should I solve this question? Okay. So there is this diagram. What we do here is we'll take x-axis in this direction. Okay. We'll take y-axis in this direction. X and y we will take in these 2 directions. We will do the components of all the forces. So 5 Newton is already in x direction. The other 5 Newton will have a component in this direction, one component in this direction. This component will be 5 cos 37. Sorry, 5 cos 53. Cos 53 is 3 by 5. So it will be 3 Newton. So the component of this force is done along this 5 sin 53. This will be 4 Newton. Okay, this force is broken into 2 components. Let's break this force along x-axis and the y-axis. So force component of this force along x-axis, it will not be along x-axis, it will be along negative x-axis. 10 cos 37, which will be 8 Newton. 10 sin 37, which will be 6 Newton. Now all the forces are either along the x-axis or along the y-axis. You can directly solve it, or you can write F1 vector is equal to 5 I cap. F1 vector was along the x-axis only. F2 vector is equal to F2 vector. So we have two component of F2, 3 I cap plus 4 j cap. F3 vector is equal to F3. There are two component, minus 8 I cap plus ka 6 j cap. F4 vector is minus 4 j cap. We add all these forces. So F net is plus 5 plus 3 minus 8 0. Plus 4 plus 6 minus 4 6 j cap is the answer. So the resultant force is in the direction of positive y direction, and it has a magnitude of 6 Newton. This will be the answer. We could have directly solved it. Like there is a 5 Newton and 3 Newton. There is a force of 8 Newton. There are two component, 4 Newton and 6 Newton. There is a force 4 Newton in this direction. So these 8 Newton will cancel out, and the 4 Newton will cancel out with 4 Newton. The resultant will be F net is 6 Newton in y direction. So what is the resultant of this? These all the four forces, 6 Newton in y direction. So the answer will be 6 Newton, and the angle with F1 will be 90 degree. F1 is along the x direction. So the angle of the resultant will be 90 degree with the F1. Is this clear to all of you? Clear? How do we solve this kind of questions? So more than four forces won't be there in NEET question. This is more than sufficient. Okay, this done. So we are done till now. Now let us talk about scalar product and the dot product of the vectors. We have not studied parallelogram, law of vector addition, and but generally NEET question are from this part only. Most of the time orthogonal condition they ask. Two vectors are orthogonal to each other, then what will be the relation between them? This kind of question are asked in the NEET papers. So this part is way too important. The other part, addition and subtraction, are indirectly used in the physics, but this is directly asked in the paper. This part is directly asked in the paper. So scalar and the dot product of the vectors. So scalar product, scalar or dot product of two vectors A and B is defined as A vector dot B vector. We define dot product like A vector and A vector dot B vector. So basically there is a one important point. We can add two vectors, we can subtract two vectors, we can multiply two vectors, but we cannot divide two vectors. Remember this thing, we cannot divide two vectors. One vector cannot be divided by the other vector. We can multiply two vectors. One vector is multiplied to other vector, but multiplication is done in two ways. When you multiply one vector with the other vector and you get a scalar result, then you are doing the dot product or the scalar product. When you are multiplying one vector and with the other vector and you are getting a vector result, the result of the product is a vector, and that is called the vector product or the cross product, that we will discuss after this. But when you are multiplying two vectors and you are getting a scalar value, scalar is the output of the product, then you call it vector dot product or the scalar product. Got it? So you represent a dot product like that. you are doing dot product of A and B. So A dot B is the representation of the dot product of A and B. So dot product of A and B is defined like AB cos theta, where theta is angle between A vector and B vector. So these are 2 points, very important point. Or what is A and B? A is the magnitude of A vector, B is the magnitude of B vector, and multiply with the cos theta. Dot product of 2 vectors gives a scalar result. That's why we call it vector product. We call it scalar product. That's why we call it scalar product. The dot product of 2 vectors give a scalar result. That's why we call it dot product is positive if theta is less than 90 degree, is 0 if theta is equal to 90 degree, and negative if theta is greater than 90 degree. So it can be positive, negative, or 0 based on the value of the theta. Dot product of two orthogonal vector orthogonal vectors means when they have theta equal to 90 degree, angle between both the vector is 90 degree. The dot product of two orthogonal vectors is always 0. It should be 0. The dot product should be 0 in case of the orthogonal vector. So if two vectors are given as orthogonal vectors, their dot product should be equal to 0. Okay? The dot product of the two orthogonal vector is equal to 0. This is the condition of the orthogonality of the two vectors. So this is all about the dot product of two vectors. Okay, how do we do the dot product of the vectors? So one way is, if you know the magnitude of A vector, you know the magnitude of B vector and the angle between them. Suppose vectors are given like this. This is A vector, this is B vector, and the angle is given as like theta is given like 60 degree. And A vector magnitude is suppose 3, B vector magnitude is suppose 4. This is given. A vector dot B vector will be equal to 3 into 4 into cos 60, which will be equal to 6 unit. Okay, this is positive. This is one example of dot product. But all the time vectors are not given like this. Sometimes vectors are given like I cap, j cap and k cap. How do we do the dot product in those cases? How do we do the dot product of the, if the vector is given like I cap, j cap and k cap format? Is there a particular way of doing that? If a vector is given in the form of I cap, j cap and k cap. So there are some important rules. Dot product of I cap and dot product of I cap is equal to, so this is a unit vector, this is also unit vector, and angle between both the vector is 0 degree. Magnitude of this is 1, magnitude of this is 1, or cos 0 is also 1, so it will give you 1. So when you do the dot product of I cap and j cap, the angle between both is 90 degree, it will be 0. When you do the dot product of I cap and k cap, the angle between I cap and k cap is 90 degree, it will be 0. J cap dot j cap, again they both are in same direction, angle will be 0, cos 0 will be 1, 1 into cos 0, which is 1. J cap dot k cap, that is also equal to 0, 90 degree angle. K cap dot I cap, 0. K cap dot j cap, 0. K cap dot k cap, this will be equal to 1. Okay, so this will be equal to 1. These all formulas you have to keep in mind. Now what if a vector is given like this? A vector is equal to A1 I cap, A2 j cap, A3 k cap, and a B vector is given like B1 I cap, B2 j cap, B3 k cap. Now we want to do the A vector dot B vector, which is A1 I cap, A2 j cap, A3 k cap dot B1 I cap, B2 j cap, B3 k cap. So when you multiply these two, A vector dot B vector, you multiply this with this. So magnitude of this A1, magnitude of this is B1, but the angle between I cap and I cap is 0. It becomes A1 B1. When you multiply with this vector, I cap and j cap, they have 90 degree angle, so the product of these two will be 0. Product of these two will be 0. Okay. Now I am multiplying this with the remaining 3. When I multiply this with this 0, this with this, it will be A2 B2. This with this 0. When I multiply this with this 0, this with this 0, this with this A3 B3. This will be the resultant of A dot B. So this way we find the dot product of two vectors. So we have to just simply multiply I cap with I cap, j cap with j cap, k cap with k cap. We'll get the. So there will be two different type of question can be asked. If the vectors are given in this form, then dot product will be like this. If the magnitude of A vector, B vector, and angle between A vector and B vector is given. If angle is given and magnitudes are given, then A vector dot B vector will be simply magnitude of A, magnitude of B into cos theta. So if theta is given, write the vector like this, and if vectors are given in this format, write the dot product of vectors like this. Is this clear to all of you? The dot product is clear to all of you? So Special class link is pinned in the comment box. You can enroll for the special class. Tomorrow at 2 p.m. we will be solving more numericals on this part. So for the practice, do not forget to register for the special class. Link is there. Link is pinned in the chat box. Okay. There are few applications of the dot product. The kind of questions are asked on the dot product. What are those two applications? Yes, 2 p.m. 2 p.m. there will be class. Get yourself enrolled for this class. Work done by a constant force. See, work done by a constant force is given by this formula. Work done by constant force is equal to F dot S. This is the formula of the work done by the constant force. So you simply do the dot product of the force and the displacement is the work done by the constant force. Power of the force. Power of force is equal to F dot V. So when you do the dot product with the velocity, you get the power of the force at any time t. So formula of the power is F dot V. Formula of the work done by the constant force is F dot S, where S is the displacement. S is displacement vector. Displacement vector. So these two are the very important application of the dot product. One is we find the work of the constant force. We find the power of the force by doing the dot product of the force and the velocity, or work done is the F dot S. Clear? I hope all the concept covered till now are pretty much clear to you. Done. Okay, let's move to the next application. If two vectors are given like A vector is equal to A1 I cap, A2 j cap, A3 k cap, and B vector is given like B1 I cap, B2 j cap, B3 k cap, and we have to find the angle between both. Angle between A vector and B vector. How do we find the angle between A vector and B vector? So there is a simple method. We know A vector dot B vector is equal to AB cos theta. So cos theta is equal to A vector dot B vector divided by magnitude of A vector. A is magnitude of A, magnitude of B vector. So A dot B, we get it from here, A1 B1, A2 B2, A3 B3, and we divide with magnitude of A. So magnitude of A is A1 square, A2 square, A3 square. Magnitude of B, B1 square, B2 square, and B3 square. This is the way to find the angle between two vectors given in that format. See, one vector is given like 2i cap plus 3j cap plus 4k cap, another is given like minus 2i cap plus 4k cap. How do we find the angle between two vectors? This is the, whenever there is a question of angle between two vectors, whenever there is a question of angle, always think about this concept. Okay, always think about this concept. This is the way we find the angle between two vectors. Clear? How do we find the angle between two vectors? This is the way. Please don't forget to like this session, subscribe to our this YouTube channel where all the faculties of this channel are dedicatedly covering the entire syllabus in this 75 days marathon series. This is my third lecture on the physics, and we two faculties are covering the physics syllabus. I'll be teaching you 11th part. There is Yavar sir who will be teaching you 12th part. So subscribe this channel. You will get the complete syllabus coverage of the physics, chemistry and biology, all the three subjects for NEET 2024. We are trying our best. Like, I never took a YouTube session of more than 2 hours, but when I see the energy level of the other faculties on this channel, the dedication of their about their commitment, fulfillment of the commitment, I am very motivated to take the session of 6 hours or 7 hours, whatever time it takes. I'll complete this topic, vectors, differentiation and integration, and only then I'll end this session. I'll give you a dinner break also, but after completion of the vector part. So, and one more thing, we are not just wasting the time on the very unrelevant topics. We are covering because the basics is required to understand the physics, and that basic part, after once this part is over, we can accelerate the syllabus, and the other topics can be completed in the less time if you understand the basic concept of the mathematics. That's why I am giving this much time to this topic on vectors, mathematical tools. So this is the second class on mathematical tool. First topic I covered was the units and dimension. Second was the functions, trigonometric functions, second lecture. That was of 3 or 4 hours long lecture. And the third lecture is vectors and the calculus. Calculus I could not complete in the previous lecture. That's why I'll cover that in today's marathon session. Okay, let's try to complete vector in the next 1 hour so that I can give you a dinner break, and after that we can start the differentiation and the integration part of the basic maths. Now we are going to talk about the component of the vector along the other vector. So suppose there is a vector, there is this vector, this is the A vector, and this is the B vector. This is B vector, this is A vector, and this angle is theta. I want to do, and they are given like this, I cap, j cap and k cap. I want to do the component of B vector along A vector. So component of B vector along A vector. What will be the component of B vector along A vector? What will be the component? It will be B cos theta. So B cos theta will be the component of B vector along A vector. We already know AB cos theta is equal to A vector dot B vector, which is A1 B1, A2 B2, A3 B3. So we have to find B cos theta. So it will be equal to A1 B1, A2 B2, A3 B3 divided by magnitude of A, A1 square, A2 square plus A3 square. This is the component of B vector along A vector. It is quite simple. AB cos theta is equal to A vector dot B vector. So if we want to find the component of B vector along the A vector, it will be B cos theta. So we keep the B cos theta on the one side, this part on this side, A we took the other side, A dot B is that one, and we divided with the magnitude of A. and that way we got the v cos theta. So v cos theta is the component of the v vector along the a vector. So these are the 4 applications of the dot product. Dot product we have covered, applications we have covered. Now we are going to solve some numerical on it. So this is the question number 10. There are total 18 questions in the vector. A force F vector 3i cap plus 4j cap act on the body and displaces it by displacement minus 2i cap plus 4j cap meter. Then the work done by this force is. What is the work done by this force during this displacement? This is very easy question. Each one of you can answer this question. What is the force? What is the work done by this force during the displacement of minus 2i cap plus ka 4j cap? What is the answer of this question? So work you can easily find. Work you can easily find. So what is the method to find the work is? Work is equal to F vector dot S vector. What is F vector? 3i cap plus 4 j cap dot minus 2i cap plus 4j cap. So work is equal to minus 6 plus 16. It will be 10 joule. And this is the answer. Done. This is a way too easy question. Okay. So this kind of questions are asked in the NEET paper. So this is a NEET level question and it is way too easy. So there is one more question. Yes, I forgot to cover this thing, but I have already taught you, na? Dot product of two orthogonal vector is always 0. So if two vectors are orthogonal, their dot product should be equal to 0. So there is a one question. A vector of 2i cap plus 3j cap plus 8k cap is perpendicular to the vector 4j cap 4i minus 4i cap plus alpha k cap. और आप बोल सकते हो इसको orthogonal. Whenever orthogonal is mentioned, you do the same thing. Orthogonal means they are perpendicular to each other. If two vectors are perpendicular to each other, they are called orthogonal vectors. A vector of 2i cap plus 3j cap plus 8k cap is perpendicular to the vector 4j cap minus 4i cap plus alpha k cap. Then the value of alpha is, out of these 4 options, which option is the correct option? Which option is the correct option? Which option is the correct option? Out of these 4 options, which is the orthogonal vector? Can you tell me the answer? Which out of these 4 is the orthogonal which is the value of alpha for the orthogonal? So if let's call this vector a vector and this vector as b vector. So a dot b should be equal to 0 if a is perpendicular to b vector. So a dot b is 2 into 4, 8. Minus ka 4 into 2, 4 into 3, 12. 8 into alpha, 8 alpha. This should be equal to 0. 8 alpha is equal to 4. Alpha is equal to 1 by 2. This is your answer. So 1 by 2 will be the correct option. 1 by 2 will be the correct option. Okay. B option is the correct option. Most of you were able to find the answer. Find the angle made by F vector, which is I cap plus J cap plus cut root 2 K cap with positive Y axis. What is the angle made by this force vector with positive Y axis? So all the applications of the dot product we are going to cover. So this is the third application where I told you na, we can find the angle between two vectors with the help of the dot product. So are you able to solve this question? This is the question number 12. 12th question is just You are just about to solve the question number 12. Can you solve this question? Can you solve this question? Find the angle made by f vector I cap plus j cap plus 2 root 2 k cap Newton with the positive y-axis. Angle made by this vector with the positive y-axis. Answer to this question. Please don't forget to like the session, subscribe the channel. This wonderful channel is going to help you throughout your preparation for NEET 2024. So we have to find the angle made by this force vector with the positive y-axis. What I can do is I can take a vector, unit vector in the positive y direction. So z cap. So if we are able to find the angle between j cap, if I am able to find the angle between j cap and this force vector, that will be the angle with the positive y-axis and the force, because j cap is in the direction of the positive y-axis. Okay, so there are two vectors. One vector is f, which is I cap plus j cap plus root 2 k cap, and the other vector is, let's call it a vector, which is j cap. The magnitude of a vector is 1 unit. Okay, angle cos theta will be equal to f vector dot a vector divided by f ka magnitude divided by a ka magnitude. So multiply with them, it will be 1, j cap 1, divided by magnitude of this 1 square plus 1 square plus root 2 ka square, and magnitude of this will be 1. Magnitude of this is 1. It comes out to be 1 by 2. So cos theta is equal to 1 by 2. So theta will be equal to 60 degree, and this will be the answer. So D option is the correct option. So D option will be the correct option. Is this clear to all of you? Each and every concept is clear. 33 slides we have covered till now. 33 slides are done in the last 2.5 hours. So is this clear to all of you? Question number 12. Let's talk about the cross product or the vector product. Cross product of the vector product. If product of two vectors gives us a vector result, then such product of two vectors is called vector product. So result of this two vectors, result of the product of two vector is product, is vector, then such vector is called the, such product is called the vector product. How do we define the vector product? A cross B. This way we define the cross product or the vector product. We define cross product like this: A cross B is the cross product of the two vectors, and it is equal to AB sin theta n cap. It is equal to AB sin theta n cap. Theta is angle between A vector and B vector. What is n cap? N cap is the unit vector which is perpendicular to which is perpendicular to A vector, B vector and plane containing A vector and B vector. So n cap is a vector which is perpendicular to A vector, perpendicular to B vector and the perpendicular to plane containing A vector and B vector. This vector is given by right hand, n cap is given by a right hand thumb rule. Okay, n cap, direction of n cap is given by right hand thumb rule. So the magnitude of A cross B is equal to AB sin theta, but this is a vector. See, product of A cross B, cross product of A cross B is a vector which is perpendicular to A vector, perpendicular to B vector and perpendicular to the plane containing A vector and V vector. How do we find the direction of n cap? How do we find the direction of n cap? This is a very important question. Cross product. Many students struggle in the cross product. Where do we use this cross product? This cross product is used in rotational motion. Torque. Torque is R cross F. Torque is the R cross F. Angular momentum. R cross P. Where else we use the cross product? Magnetic force. We use their R, like cross product, magnetic field and magnetic force. There we use cross product. So cross product we must learn here. So suppose these two vectors are given. Let's say this vector is A vector and this vector is B vector. Okay, this angle is theta. How do we find the direction of the n vector, n cap? Direction of n cap is very important to understand. See, I told you n cap is a unit vector which is perpendicular to A vector, B vector and plane containing A vector and B vector. So A vector is this, B vector is this. A vector perpendicular to plane containing A vector and B vector is this. See, plane containing A vector and B vector is this. This plane contains A vector and B vector. So there are two directions of a vector which is perpendicular to this plane. This direction and other direction into the plane of the board. There are two possibilities of n cap. Either it will be outward, either it will be inward, because n cap is perpendicular to plane containing A vector and B vector. N cap is perpendicular to plane containing A vector and B vector. So A vector and B vector lie in the plane of the board. So there are only two possible directions of n cap. Either it will be outward or either it will be inward. So when we are doing A cross B, what are we doing? A cross B. So we are crossing A towards B. So we take our right hand. This is my right hand. Okay. We put both the vectors tail to tail. We identify the small angle. This is the small angle. We are doing A cross B. So I'll put my finger of right hand towards A vector. And this part should be towards B vector. So either I can put like this or I can put like this. What did I say? This part should be towards B vector and fingers towards A vector. Okay. So can I put it like this? No. This part is not towards the B vector. B vector is on that direction, that side, like this. Okay. So my fingers are along the A vector. My palm should be at this point. Now cross A towards B along a small angle. This is a big angle. No, not along big angle. Along the small angle, A cross B. The direction of thumb is into the plane of the paper. The direction of thumb is into the plane of the paper. So in this case, A cross B will be into the plane of board. Okay. What if we are doing B cross A? What if we are doing B cross A? Now, we are crossing B towards A. We are doing B cross A. Now, my finger should be towards B vector and this part should be towards A vector. Now, I'll place my hand like this and this part should be towards A vector. Now, I'll cross my hand towards this and thumb will give the direction of n cap. So, the direction of this vector, the result of this vector outward to the plane of paper. Okay. So, B cross A will be outward, A cross B will be inward. Outward, inward. We were confused about only these two directions, whether it will be outward or inward. Is that clear to all of you? How do we find the inward or outward direction? Outward and inward direction. 8:30 we will give a break, मतलब 8:15 or 8:30. Cross product, parallelogram law. Vector I'll cover in without any break, and after that, before starting the differentiation, I'll give you a 15 to 20 minute break. You can easily take finish your dinner and then we start the differentiation and integration part. See, when you are doing A cross B, I am confused in two directions only. A and B, these vectors are lying in this plane. So the A cross B will be perpendicular to this. So there are only two possibilities, whether it will be outward or whether it will be inward. Okay, there are only two possibilities. So A cross B, this part should be about towards other vector. So when I am doing A cross B, so I'll place my right hand finger along A. This should be towards B. So B is in this direction. Now cross this. Thumb is into the plane of the paper. Into the plane of the paper. A cross B will be into the plane of the paper. B cross A. This should be about along towards other vector. So B cross A will be like this, outward. A cross B and B cross A are clear to all of you? Can I say that A cross B is equal to B cross A? Because magnitude of this is AB sin theta, magnitude of this is also AB sin theta. Can I say they both are equal? They cannot be equal. No. Their directions are different. Their magnitudes are equal. Their directions are different. See, A cross B is into the plane of the paper. See, this thing is a vector. This is also a vector. They cannot be same because their directions are not same. Is this clear? But we can certainly say one thing. Magnitude of A cross B, magnitude is equal to magnitude of B cross A. So when we are talking about their magnitude, they are same, AB sin theta, AB sin theta. Magnitudes are same, but A cross B is not equal to B cross A. A cross B is minus times B cross A. Got it? Clear? Clear to all of you? Clear ba? Clear hai bhai ye wala? A cross B and B cross A. Is this clear to all of you? So how do we do cross product? So if magnitude of A is given, magnitude of B is given and theta is given, then we can directly do cross product by AB sin theta. Okay? Okay. What if something like this is given? A vector is given like A1 I cap plus A2 J cap plus A3 K cap, B1 I cap plus B2 J cap plus B3 K cap. Then how do we do the cross product? So see, I cap cross I cap. What is the angle between I and I? 0. It will be 1 into sine 0. It will be equal to 0. When you do I cap cross J cap, see, I cap is in this direction, j cap is in this direction, and k cap is in this direction. So when you are doing I cap cross j cap, it will be outward. And the magnitude of this is 1, 1 on angle is 90. So 1, so it will comes out to be k cap. I cap cross k cap. You tell me what will be the direction of I cap cross k cap? You tell me the direction of I cap cross k cap. What will be the magnitude of I cap? 1. Magnitude of k cap 1. Angle between both 90. 1 into sine 90 is 1. What will be the direction? I cap cross k cap. I cap cross k cap. So I cap in this direction, k cap is outward. This part should be towards the other vector. I cross k downward. It will be minus ka j cap. Minus ka j cap. Okay, you tell me this. J cap cross I cap. What will be the direction of j cap cross I cap? What will be the direction of j cap cross I cap? J cap cross I cap. What will be the direction of j cap cross I cap? So j cap upward, I cap this. This part should be along I cap, so into the plane. It will be minus k cap. J cap cross j 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 cap. 0. The angle between both is 0. J cap cross k cap. J cap cross k cap. J cap cross k cap. So j cap cross k cap. J cross k I cap. You will never forget cross product. K cap cross I cap. 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 Okay, after cross product we will give you a break and then we start the parallelogram law and differentiation and integration. K cross I j cap. K cap cross j cap. K cross j minus I cap. K cap cross k cap is 0. So when we are doing, suppose a vector is given as a1 I cap plus a2 j cap. We are not taking a big product. b1 I cap plus b2 j cap. So a cross b, while doing a cross b, it is like a1 I cap plus a2 j cap cross b1 I cap plus b2 j cap. So a cross b will be like you are multiplying this with this 1 by 1, this into both the term. I cap cross I cap 0, first term will be 0. I cap cross j cap, I cross j k cap direction, so this into this, it will be a1 b2 k cap. Okay, this is done. Now this is multiplied to this, so j cross I, it will be minus k cap, so minus a2 b1 k cap. When this multiplied to this will be 0. So a cross b, you can simply write a1 b2 A2 B1 K cap. This is one way of doing cross product. When you forget all the thing, you can directly do the cross product like this. Okay. Now there is one more method, that is called the determinant method. Method 2, that is called the determinant method. So if A vector is given as A1 I cap plus A2 J cap plus A3 K cap, and B vector is given as B1 I cap plus B2 J cap plus B3 K cap. So what we do is, when we are doing A cross B, we simply draw a determinant we write I cap here, J cap here, K cap here. A is first, so coefficient of I cap, J cap and K cap. B is second, so B1, B2 and B3. Okay, this way we do with the help of determinant method. So A cross B will be equal to A cross B will be equal to, first we write I cap and there will be a bracket. So we will forget about this column and this row. We multiply like this into this. A2 B3 minus B2 A3. Okay. Now when we go to this, we put minus here, minus J cap. So here plus, here minus, then again plus. We forget about this column and this row. We multiply like this. A1 B3 minus B1 A3. Then again plus this third term K cap and again bracket. Now forget about this and this. This into this, this into this. A1 B2 minus B1 A2. This will be the cross product of these two vectors. Is the cross product clear to all of you? Cross product I have just covered. Is this clear to all of you? I think I should cover this on. I should add one more slide. Hai na? How do we do the determinant part? Determinant, I hope you did not understand. Na? So this is I cap, J cap, K cap, A1, A2, A3, B1, B2, B3. We are doing A cross B. Okay. What we will do is, first I will write I cap here, there will be one bracket, minus J cap here, there will be bracket, plus K cap here, there will be bracket. So plus, minus, plus, I cap plus J cap with minus, K cap with plus. This you have to remember. First will be plus, second will be minus, third will be plus K cap. Okay. Here something will be multiplied. When I am talking about I cap, I forget about this and this. These two are remaining. So we multiply like this. This into this, this into this. Got it? We multiply these two minus these two. So this multiplication and this multiplication. So A2 B3 minus ka B2 A3. When I am writing J cap, then we forget about this and this. This multiplied by this multiplied by this. So A1 B3 minus B1 A3. When we talk about this K cap, We forgot about this and this. This into this, this into this. A1 B2 minus B1 A2. This will be the cross product of A and B. Is this clear now? Clear now? In which center did you teach? I don't teach offline, only online I teach. Right now I am in Bangalore. I'm taking class from there only. Is this clear to all of you? Clear? Clear? Okay. So solve this question then. If this is clear to all of you, then you must be able to find the answer of this. So A vector and B vector are given. Find the A dot B and A cross B. Both you have to find. I'm waiting for your answers. Please try to solve these two questions by your own. After these two questions, I'll give you a break of 15 minutes. Then you enjoy your 15-minute break, dinner break. And after that, we start the class again. Right now, I am in Bangalore. I was teaching in Kota last month, till November 10th, before joining Unacademy. What is B? B vector is that 2 I cap plus ka j cap. This is I cap. Okay, that is I cap. That is B vector is 2 I cap plus j cap. Then find A vector dot B vector. Find A vector cross B vector. A vector dot B vector आ गया आपका? That is equal to 3. Yes. The main is this A cross B. How do we find A cross B? A cross B is important. A cross B is very, very important. Very, very important. Guys, please like the session here. Like at least likes should cross 400 by the end of the session. We should be able to cross the 400 mark by the end of this session, because I am going to teach you the 3 very, very big topics in next 6 hours. It will be a 6 hours long session. Marathon is the 6 hours long. We have completed 3 hours. In 3 hours, I am able to teach you only dot product, cross product, and the only few things I am able to complete. After this, I will give you a break. We'll bring 1000 like. Thank you. Okay. So, how do we solve this question? A dot B is very easy. I cap is multiplied by 2 I cap. So, it will be 2 j cap multiplied to j cap. It will be 1. It is 3. And this is the answer. Balle balle. You all happy? Yes. This we will do with the help of determinant method. I cap, j cap, k cap. So first there is a vector. So we will take the coefficient of a. 1, 1 and 1. Okay. B 2, 1, 0. There is no k cap. So I cap we write here. I cap like this. So 1 into 0, 0. Minus ka 1 into 1, 1. Minus ka j cap. J cap is this. 1 into 0, 0. 2 into 1, minus ka 2. Plus ka k cap. You should be able to do like this, like I am doing. K cap, you forget about this and this. 1 into 1, 1. Minus ka 2 into 1, 2. So you get the answer is equal to minus I cap plus ka 2j cap minus ka k cap. And this will be your answer. So A cross B will be equal to this. Done, 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 done. Oh, solution is already there. We don't need. So before we start the next topic, I'm giving you a 21-minute long break because at 8:30 we start the class. You take a dinner break. It's 8:30 or time is wrong. I was very energetic today. Like I can teach another 3 hours without any stop. But okay, it's okay, no problem. So sharp 8:30 we meet. It's already 8:10. 20 minutes I am giving as a break, so you can refresh yourself and uh, be here at sharp 8:30. Okay, we are going to cover the parallelogram law of vector addition. We are going to cover the displacement. We are going to cover differentiation and integration and their application. So almost 3 hours class is left. After 8:30 to 11:30 we will continue and cover these 3 topics. Okay, bye. Hello guys, welcome back to the class. It's already 8:30 and we have to cover three remaining topics. That is, one is the parallelogram law of vectors and the other one is the differentiation integration. So I hope this 20-minute break was more than sufficient for all of you to this as a break. It was sufficient time was given to you. So we are again going to start the class. Let's join others as well. If English speaking is a physical quantity, then the measurement of the amount of this physical quantity which I speak during these classes is more than the amount, the magnitude which I have almost spoken in my entire life. that much English I speak in the 3-4 hours with you people. Okay, so basically class was supposed to resume at 8:30 and still few are missing, but we cannot stop here. We have to keep going on. Okay, और बताओ सर क्या हाल चाल? बढ़िया. Okay, so we have covered what topics we have covered. Let's take a look at it, what we have done till now. So it all started with the definition of the vectors. Okay, oh my god, so much slides to go back. No. Yes, it all started with this crash course, amazing crash course, NEET Endgame, which is starting from 2nd of January 2024 for the for NEET 2024. So from 2nd January you can join this amazing batch where all your favorite educators of this YouTube channel will be teaching you and will be preparing you for NEET 2024. There is a early bird price also, 7,999, and try to apply this force, not this force, try to apply this referral code Kailash 10, so you get maybe you get the additional discount. We started with the physical quantities types, vector, scalar. We talked about the exceptions, representation of the vector, important point about the vector, 2 points I missed which I covered later, angle between two vectors, question on that, then triangle of vector addition, then important point about the triangle of vector addition, few questions on the triangle of vector addition, the addition questions we have done, then 2 points we missed which we covered in the unit vector, how to make a vector of I cap, j cap and k cap format, component of the vectors along the xyz axis, this we have covered already, unit vector, how to find a unit vector, what is the component of the vector, what is the magnitude of the vector, this we have covered, question on that, two amazing questions we solved, addition and subtraction of the vector in I cap, j cap and k cap format, we covered that as well. We solved one question on that, one question from Newton's laws of motion we have solved. Then we move to the scalar and dot product of the vector, all the applications. I hope this part is clear to all of you. Then we talked about the applications of the vectors. Then we solved few numericals on that as well. Condition of orthogonal, two vectors are orthogonal to each other, then their dot product should be equal to 0. Angle made by a vector with a x, y, z axis or with some other vector. Cross product we have covered, and application of the cross product, I mean we solve this question as well. So now class, we start the class again. So now we are going to talk about the very important law. Most of the faculties teach this law in the beginning only, and that law is the parallelogram law of the vector addition. Parallelogram law of the vector addition. What this law says. This is also about the addition. We have already covered the triangle of vector addition. That law is also sufficient, but we also have to go through this law. This will give you the numerical values of the resultant of the two vectors which are A and B. So if two vectors A and B are to be added, or the resultant of A and B we have to find. So if two vectors A and B are represented in magnitude and direction by the two adjacent side of the parallelogram, what we do, we make a parallelogram and we represent two adjacent sides of a parallelogram with vector A and B drawn from the same point, and their tail are at the same point. Their resultant vector of A and B represent the resultant vector, R vector is represented, this is extra, okay, is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. So by this definition you don't understand anything. I'll have to explain it. What is the meaning of this? All. So if there is a vector which is the A vector, okay, there is a vector which is the B vector, we have to add these two vectors, or we have to find the resultant of these two vectors. So what we will do is, we will put them like head to tail. No, not head to tail. Head to tail is for the triangle of vector addition. So we make a parallelogram by drawing these vectors from a point, and these two vectors should represent the adjacent side of the parallelogram. So is there a parallelogram? Yes, but that parallelogram is ulta parallelogram. Okay. So what we do is, we draw a parallelogram by parallelly shifting these vectors. So A is shifted to here. Now I am shifting B, and both the vectors should be drawn from the same point. So if two vectors A and B represented in magnitude and the direction by the two adjacent side of the parallelogram drawn from the same point. So B vector is also drawn from the same point. Okay, B vector is also drawn from the same point. We have to draw the parallelogram. So to draw the parallelogram, we will have to draw this line parallel to this line. So we draw this line, okay, we draw this line as well, okay. So this is the parallelogram, okay, this is the parallelogram. This is the vector A, this is the vector V, this is the angle between both the vectors. So what we have done is, we have completed first two lines. If two vectors A and B represented in magnitude and the direction by the, you also read these lines, then you will remember this definition. So read these lines with me. If two vectors A and B represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from the same point, from a point. So your family member will be watching you and like they will saying, क्या करता रहता है? तो मम्मी पापा क्या करता रहता है, पता नहीं क्या बोलता रहता है. खैर. So if two vectors A and B represented in magnitude and direction by the two adjacent side of the parallelogram drawn from the same point, their resultant vector, the resultant of these two vectors, is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. So there are two diagonal. One will be this, one will be this. So we don't have to take this diagonal. No. The diagonal which is drawn from the same point will be the resultant of A and B. So now we have to draw a diagonal from the same point, from this point only, and that will represent the direction of that will represent the resultant of these two vectors. Okay, so this diagonal is the resultant vector, which is the A vector plus B vector. So the magnitude, the length of this diagonal will give you the magnitude of the resultant, and the direction will be given by, and the direction is given here only. So this resultant will make an angle alpha with the A vector. The resultant will make an angle alpha with the A vector. How do we find the length of this diagonal? How do we find the length of this diagonal? The length of this side is A, the length of this side is B, this angle is given as theta. So what we do, we draw some additional lines. So we drew this line and a perpendicular on this line. These are the two additional lines. This angle is theta, so is this angle. This side is B, this side will also be equal to B, this side. This is the B cos theta, this will be B sin theta. In this triangle, right angle triangle, this is the base, this is perpendicular, base upon B equal to cos theta, perpendicular upon B equal to sin theta. So now we have a right angle triangle, this one. The length of this is R, this is base, base will be A plus B cos theta, and this is B sin theta. So R square, we apply Pythagoras, R square is equal to B sin theta whole square, A plus B cos theta whole square. So R square is equal to B sin theta whole square plus A plus B cos theta whole square. So R square comes out to be B square sin square theta plus A square plus B square cos square theta plus 2AB cos theta. B square sin square theta plus B square cos square theta is equal to B square. So R square comes out to be A square plus B square plus ka 2AB cos theta. This is the resultant of, formula of the resultant of the two vectors where theta is the angle between both the vectors. This is the formula. Okay. What is the value of alpha? So tan alpha I can write from here. This is the right angle triangle, this one, bigger one. Tan alpha is equal to B sin theta divided by A plus B cos theta. So the angle made by the resultant vector with A vector will be alpha, and tan alpha is equal to B sin theta divided by A plus ka B cos theta. R square is equal to A square plus B square plus 2AB cos theta, and like this we get the both the formula. Are these two formula clear to all of you? Are these both formulas clear to all of you? So this is the parallelogram law of vector addition. So we can deal with the two vectors at a time. We can deal with the two vectors at a time. If we are dealing with the more than two vectors, then triangle law of vector addition is more helpful. Okay? This is clear to all of you? So let's move to the next page. So R vector, or you say R square, is equal to A square plus B square plus 2AB cos theta. So R is dependent on theta. R is function of theta, and theta is what? Theta is the angle between A and B. So when cos theta is maximum, then R will be maximum. R will be maximum when cos theta will be 1. When cos theta is 1, then A square plus B square plus 2AB will be A plus B ka whole square. And there is A square plus B square, so it will be equal to A plus B. R is minimum. It is when theta is equal to 0 degree. R is minimum when cos theta is minimum. Cos theta minimum is -1 at theta equal to 180 degree. So this will be minus 2AB. A square plus B square minus 2AB is A minus B ka whole square. So this is A minus B when theta is equal to 180 degree. Okay, so minimum value of R is this, maximum value of R is this. This we have already covered. So R will be less than or equal to A plus B and greater than or equal to A minus B mod. This is the value of R. Okay, this is the value of R. R is given by this formula, R equal to, or we can write R equal to root over a square b square plus 2ab cos theta. R is equal to this. Clear? This is nothing new in this. This all we have already covered that. There is one very important thing. This is very important thing. A resultant of two vectors is equal to 0 when they both have equal magnitude and opposite direction. So this is nothing new in this. Opposite direction. This is already you know. Okay. Resultant of three equal magnitude vectors is 0 if resultant of three equal magnitude vector is 0 if they form an equilateral triangle. This will be the case. Why? They all are of equal magnitude. They must form this equilateral triangle like this. They are of equal magnitude as well. So the length of all the sides will be same. So this angle will be 60 degree. This will be 60 degree. This will be 60 degree. What will be the angle between this vector and this vector? 120 degree. You will shift it here, then this angle. Angle between this and this 120 degree. Angle between this and this 120 degree. So if three vectors are acting like this, this is an important case. So if three vectors of equal magnitude, suppose F and F are acting at 120 degree angle, 120 degree angle, 120 degree angle, then the net of these three will be equal to 0. Net of these three will be equal to 0. There is a Lami's theorem as well. There is a Lami's theorem as well. But in case of three equal forces and whose resultant is equal to 0, they must have 120 degree angle between any two forces. There must be 120 degree angle between any two forces. And if four equal forces are acting on a particle and the resultant is 0, then they must be, between two forces, two adjacent forces, the angle should be 90 degree. Then they must form a square. Okay. This is easy. This is not that difficult. This I just I thought I should not miss this part. That's why I have covered. Otherwise, this was the part which I was supposed to cover. Okay, let's solve this question. Two vectors of equal magnitude have a resultant equal to either of them in magnitude. Then the angle between them is. Tell me the answer of this question. So two vectors of equal magnitude have a resultant equal to either of them. Equal to either of them. So they both are equal and the resultant is also equal to either of them. Then the angle between them is. So if two vectors are of equal magnitude and their resultant is also equal to their magnitude, what is the angle between them? What is the angle between them? These are the points which students directly remember. These are the points which students directly remember. In case of two equal magnitude vector, what should be the angle so that the resultant is of the same magnitude? What will be the answer? 90 degree. So two students answered the 90 degree. Third one also answered the same 90 degree. So you could have tried to solve this question actually, na? So let's say A vector is equal to B vector, not B vector, equal nahi, the magnitude are equal to B vector is equal to A. Let's call it equal to A. So R vector is equal to R square is equal to A square plus B square plus 2AB cos theta. Okay? So put a resultant is also equal to A. All three are same. Resultant is equal to either of the two vector, and those two vector are also same. So we put A here, cos theta. This will cancel out. So cos theta comes out to be minus 1 by 2. Cos theta negative. It means theta lies in the second quadrant. Cos theta is negative in the second quadrant. So theta will be greater than 90 degree. So put theta is equal to 90 plus alpha. Theta equal to 90 plus alpha. Cos 90 plus alpha is equal to minus 1 by 2. This will be equal to minus sin alpha. When you remove 90, cos is converted to sin. 90 plus alpha second quadrant, their negative minus will come. So sin alpha is equal to 1 by 2. So alpha will be equal to 30 degree. So theta will be equal to 120 degree. So theta will be equal to 120 degree. So when angle between two vectors is 120 degree, their resultant will be equal to their magnitude. The angle between two equal magnitude vector is 120 degree, then their resultant will have same magnitude as that of the vector. So suppose this vector is one vector and this is the other vector. Not let's do this by parallel triangle of vector addition. So this vector is A vector, this vector is B vector. Angle between them is 120. See, angle is this, not this. When you place the tail of this here, this angle will be 120 degree. They both are equal in magnitude. So resultant is what? Resultant will be this. This angle is 60 degree. Magnitude of this and this is same. So these two angle will also be equal. This will be 60 degree. This will be 60 degree. So equilateral triangle will form. They both are same magnitude and this is of the same magnitude. Then it should form the equilateral triangle. The angle between A and B should be 120 degree. So when two vectors are yes, this is the same concept. Yes. So 120 degree will be the answer of this question when the resultant of two vectors of equal magnitude is equal to magnitude of either of the vector. Okay? Done? So two vectors of equal magnitude have the resultant equal to either of. So there is a concept, like when angle between both vector, so resultant of two equal magnitude vectors. So listen, there is resultant of two equal magnitude vector. When angle between them is 60 degree, so resultant comes out to be root 3a or root 3b. So when two vectors of equal magnitude are added and their angle between them is 60 degree, the resultant will be equal to root 3a or root 3b. How do we do this? So one vector is like this. Angle between them is 60 degree. Other one will be like this. The resultant will be like this when you draw the parallelogram. The parallelogram will be like this. This is A vector, this is B vector. The angle between them is 60 degree. Then this resultant will be root 3a. Okay? The resultant will be root 3a in this case. You remember this formula. So if two equal magnitude vectors have angle 60 degree between them, the resultant will be √3 times A. Can you remember this formula? Okay. When the angle between two vectors is 90 degree, equal magnitude vector, resultant angle is 90 degree, the resultant will be √2A. So if this is A vector, this is B vector, magnitude of A vector is equal to magnitude of B vector, then the resultant is equal to √2A. Okay. Here also magnitude of A vector is equal to magnitude of B vector is equal to A. Then resultant is √3A. When angle between both vector is 90 degree, the resultant will be √2A. When angle between both vector is 120 degree, this vector is like this and this vector is like this. So parallelogram will be like this. The resultant vector will be this. This is A vector, this is B vector, this is R vector, which is equal to A. So resultant will be equal to A. Okay. Can you remember all these three cases? When angle between two vectors is 60 degree, the resultant will be √3A. Two equal magnitude vector, 90 degree, √2A. An angle between two vectors is 120 degree, the resultant will be equal to A. If you remember these formulas, you will not have to solve them again in the exam. Otherwise, you have this formula. Just apply this formula, R square is equal to A square plus B square plus 2AB cos theta. This will give you the result in always. Okay, this is the formula which will give you the result. When two vectors, listen, when two vectors are of equal magnitude, the resultant will be along the angle bisector. Resultant will make 30 degree angle and 30 degree angle. Here 45 degree angle, 45 degree angle. Here 60 degree angle, 60 degree angle. So when these two vectors are of equal magnitude, their resultant will be angle along the angle bisector of their angle. Okay. This part is done. Let's solve some numerical on this. So question number 15 is waiting for you. If greatest and the least resultant of the two forces acting at a point are 17 Newton and 7 Newton, then find the resultant of both when acting orthogonally. I want all of you to solve this question. When greatest and least resultant of two forces acting at a point is 17 Newton and 7 Newton, find the resultant of both when acting orthogonally. You have to find the resultant of both the forces when they are acting orthogonally. Can you solve this? Greatest and the least resultant of the two forces acting at a point is 17 Newton and 7 Newton. What is the answer of this question? Tell me the answer of this question. What is the answer of this question? So what is the greatest and least? Greatest value we get when both the forces are acting in the same direction, F1 plus F2, that is 17 Newton. Least value when they are acting opposite to each other, that is 7. We add them. So 2F1 is equal to 24. F1 is equal to 12 Newton. F2 is equal to 5 Newton. When they are acting orthogonally, theta is equal to 90 degree. Then resultant is equal to F1 square, F2 square plus 2F1, F2 cos 90. So resultant square is equal to 12 square plus 5 square which comes out to be 169. R comes out to be 13 Newton, and this will be your answer. D option is the correct option. Was anyone able to find the answer? D option will be the correct option. This is a very easy question which you can solve. Yes. Srinath, you were able to find the D option. Okay, it was the correct option. D option is the correct option. Orthogonally means they are acting at 90 degree. Question number 16. This one is a little bit difficult question. The vector sum of two forces is perpendicular to their vector difference. The vector sum of the two forces. Okay, you tell me one thing in the end of this vector topic, that if I have missed any concept which is taught to you in your classes or somewhere wherever you study for your NEET physics, if you find a single concept that sir you did not teach us this concept, then let me know. I'll cover that in the end. Okay. Anything which is important, I hope I have already covered. Still, if you find anything that sir this is not covered, you can let me know. Otherwise, I'll consider that I have covered each and every topic. The vector sum of the two forces is perpendicular to their vector difference. In that case, the force, the vector sum of the two forces is perpendicular to their vector difference. In that case, the force. This is very, very difficult. Very, very difficult question. Very, very. Are you able to solve this question? So many of you are saying B and C option to D option. Wow, what a variety. So, vector sum of two forces. Let's call those forces A and B. So, A and B. So, vector sum will be A vector plus B vector. Okay. This will be the vector sum. And their difference will be A vector minus B vector. And they both are perpendicular. A vector plus B vector is perpendicular to A vector minus B vector. That means A vector plus B vector dot A vector minus B vector should be equal to 0. See, this is the sum of the two vectors. And this is the difference of the two vectors. They are perpendicular vectors. That means their dot product should be equal to 0. So when you multiply A vector with A vector, you are doing dot product. So magnitude of A vector is A, and their angle will be, angle of A vector and A vector will be 0. So this comes out to be A square. When you multiply this and this, minus ka AB cos theta. When you multiply this and this, plus ka AB cos theta minus ka B square. This should be equal to 0. So AB cos theta and AB cos theta gets cancelled out. A should be equal to B. The magnitude of both vectors should be same. This will be the answer. So are equal to each other in magnitude. So both the vector will be equal to each other in magnitude. So the magnitude of both the vectors should be equal to each other. Got it? Yes, you all were, like most of you were correct. B option is the correct option. Do you like this font? Is this font better than the previous one, or the previous one was better? Like, I found this very attractive. Like, it is some, it feels like I have written these notes. This one is better, na? Yes. Okay. So this was question number 16. There are only 2 questions left. So we are going to talk about the displacement vector. Now this is the last topic of the vector, and that is the displacement vector. And the displacement questions are also the part of the vector. Basically, I'll teach this part in the kinematics as well, but let's cover displacement vector here only. Position vector and the displacement vector. So suppose I draw xy axis. Okay. X-axis, this is the y-axis. A particle at this position, this is the initial position. Initial position. X1, Y1, only we are talking about the XY plane only, okay? So this is the position vector. This is called the position vector. A vector joining origin to the position of the particle. This is the initial position vector. Particle has gone from this point to this direction, then this direction, then this direction. Particle reaches, this is the final position. Here it is the particle. Here particle reaches after some time. And this is coordinate of this is x2 comma y2. So this is final position vector. From initial position to final position, a vector joining initial position to final position is called the displacement vector. This is called the displacement vector. And these are the part displacements: S1 vector, S2 vector, S3 vector. Okay. So it might cover this distance or this path in steps, and those are the displacement vector. So first position vector we define. Position vector. So initial position vector is, our initial vector is x1 I cap, x2 j cap, x3 k cap. Final position vector is, oh, what I have done, y1 j cap. Final position vector is x2 I cap plus y2 j cap. These are the 2 position vectors. We have already studied this, 0, 0, this vector and that vector. So can I write r initial vector plus displacement vector is equal to r final vector? So displacement vector is equal to r final vector minus r initial vector. Displacement vector will be written like this. So displacement vector comes out to be x2 minus x1 I cap, y2 minus y1 j cap. You can directly write displacement vector from here. We are not going into very much detail of this displacement. We will cover that part in the kinematics topic, okay? Distance and displacement, what are the distance and displacement? From here we can write the displacement vector. This can also be written like s1 vector plus s2 vector plus s3 vector. So displacement vector can also be written like S1 vector, S2 vector plus S3 vector. So this will be the displacement vector. So displacement vector is S1 vector plus S2 vector plus S3 vector. So whenever there is a part displacement, you just simply vectorially add them and you get the net displacement. So if displacement is 0, if displacement vector is 0, then S1 vector, S2 vector and S3 vector must form a closed loop, must form a closed loop. So if displacement, net displacement is 0, particle return to the starting point, then all the three displacement vector must form a closed loop. Again, the same condition will be followed that we have discussed for the force. So there is a question, a beautiful question for all of you. I want all of you to try this question. Displacement, I am not going into that detail. Displacement I am leaving at this point, okay? Because displacement I'll teach in very detail in the next topic, kinematics. We have to cover differentiation and the integration today only. So we will move to the differentiation and the integration part just after covering this vector. So can you solve this question? Which of the following set of the displacement might be capable of bringing a car to its returning point? It should not be returning point, it should be starting point. Which of the following set of the displacement might be capable of bringing a car to its starting point? That means the displacement, there is a set of displacements, like it is moving 5 kilometer in one direction, then 10 kilometer, then 30 kilometer, and then 50 kilometer. So out of these 4 options, which of the following set might be capable of bringing a car to its starting point, not returning point? To write the returning point, I don't know. Starting point should be there, where it is started. We have to bring back this car to the starting point. So which set of the displacement might be capable of doing this, that, these? So there are 4 different displacements given and we have to find which option is the correct option. So there are these 4 displacements and the resultant of these 4 should be equal to 0. S1 vector, S2 vector, S3 vector and S4 vector should be equal to 0. So they all must form closed loop. What do you say? They must form closed loop. They should form closed loop, na? Then only the displacement will be 0. Can these 4 values form a closed loop? The 4th side is greater than the sum of the remaining 3 sides. 30 plus 10 plus 5 is 45. And 50 kilometer is greater than 45. This can never be equal to 0. This can never be equal to 0. 5 plus 9 plus 9. This is 23. Yes, the bigger side is less than sum of the remaining 3 sides. This is possible. The sum you can form a closed loop with the help of this data. 200. The bigger side is greater than 90 plus 40 plus 40, 170. Yes, this is greater. No, it cannot be the. It cannot form a closed loop. Same here. 10 plus 20 plus 40, 70. And this is 90. No, it cannot form the closed loop. Yes, I'll share these slides on the Telegram. I'll ask Wasim sir to share with you. Okay? In the main Telegram group as well and in my Telegram also. I'll share these slides. Otherwise, how will you copy the notes? It will take a... Like, I'm not giving time to Note it down. So this is clear to all of you. 17 question is done. Our last concept is subtraction of the two vectors. What is the resultant of A vector minus ka B vector? Okay, A vector minus B vector is the last concept. Whenever we have to find the change of two vectors, change of a vector, then we have to use this concept. So let us say if theta is the angle between A vector and B vector. So there is a A vector, there is a B vector. What is the angle between them? What is the angle between them? So A vector and B vector has angle theta. Okay, theta is given between angle between A vector and B vector. We have to find A vector minus ka B vector. Can I write this like this? A vector plus minus B vector. Can I write like this? You'll say yes sir, we can write. Can I call this vector a C vector? So this becomes A vector plus C vector. What is the magnitude of C vector? The magnitude of C vector and magnitude of B vector are same. What is the angle between A vector and C vector? Let's call it alpha. Alpha is the angle between A vector and C vector. So what will be the resultant of this? R dash square will be equal to A square plus C square plus 2AC cos alpha. This will be the resultant. And if we put the magnitude of C equal to B, R dash square is equal to A square plus B square plus 2AB into cos alpha. This will be the resultant. But there is a problem. We don't know the alpha. So what is alpha? Alpha is the angle between A vector and C vector. And what is C vector? C vector is the minus B vector. So you know this. If this vector is B vector, then minus B vector will be this. This will be the minus B vector. This will be the minus B vector. So if angle between A vector and B vector is theta, then angle between A vector and minus B vector will be pi minus ka theta. And B vector I am calling C vector. This is the alpha which we have used. Angle between A vector and C vector, alpha. Alpha is basically pi minus ka theta. So when you put alpha is equal to pi minus theta, so cos pi minus theta is equal to minus cos theta. So A vector minus B vector का जो magnitude होगा, that is equal to root over A square plus B square minus 2AB cos theta. Where this you remember, theta is angle between A vector and B vector. If angle between A vector and minus B vector is given, then it will be plus. Okay, what I am taking theta is the angle between A vector and B vector. That's why here it will be minus ka 2AB cos theta. Okay, cross vector ho gaya. Yes, that is already covered just before this. Before the dinner I have covered cross product and dot product. Dot product, cross product done. Parallelogram law is also done. Now we are talking about this. So where we can get previous section lectures. Previous lectures I have covered on this just this channel only. PDF I will share one more time. All the PDF, previous the 2 lectures PDF and this PDF. Combined PDF I will share. So is this clear to all of you? Subtraction of the two vectors. So this way we solve the question. So there is one very important question which is which might be asked in your exam as well. A particle moving along the circular path takes a 90-degree turn with constant speed v0. Find the change in the velocity of the particle. Very easy question. Whenever we are finding the average acceleration, this type of questions are also asked. Car question? Where is the car question? Yes, I'll share these notes. So question number 18 is, a particle is moving along the circular path, takes a 90-degree turn with constant speed v0. find the change in the velocity of the particle. Can you find the change in the velocity of the particle? Can you find the change in the velocity of the particle? Change in the velocity of the particle. Vector will be over after this question. Tomorrow there is a practice session at 2 p.m. Special class link is pinned in the chat box, and after this vector I will cover differentiation and the integration part as well. Cos 90 is 0. Cos 90 is 0. C option is the correct option. So a car is moving on a circular path. It was here, moving with V0. When it took a 90-degree turn, so the initial velocity is this, V initial is this, and V final is this. So change in velocity is delta V vector. Delta V vector will be V final vector minus V initial vector. Okay, V final vector minus का V initial vector. So V final vector is this. V final vector is this. We have to add. This is V final vector, and we have to add minus V initial vector. So V initial vector was in this direction, so V minus V initial vector will be in this direction. So resultant will be like this, and this will be delta V vector. So the direction of delta V vector will be this. What is the angle between both? 90 degree. What is the magnitude of this? V0. What is the magnitude of this? V0. So delta V vector magnitude is V0 square plus V0 square plus 2 V0 cos 90 root. So delta V comes out to be root 2 V0. So magnitude of change in velocity will be root 2 V0. So C option will be the correct option. C option will be the correct option. Is this clear to all of you? That part V final minus V initial, what will be the direction of this? So the direction of delta V vector will be in this direction. So sometimes direction related question are asked. A car is moving towards the north. It took a turn towards the west, 90-degree turn towards the west. What is the direction of the change in velocity? It will be southwest direction. It will be southwest direction. So this is the north direction, this is the west direction, and the delta V vector is coming in this direction. So west, south, southwest direction. Okay, this is a very simple question which could be asked in the NEET exam as well. Okay, so a vector is over. Vector chapter is over. Tomorrow 2 p.m. we have a discussion in a special class, like practice session in a special class. Now I am going to start new topic, that is the differentiation. Differentiation, we are going to start differentiation. This chapter is done. First part of this lecture is already over. Let's start this new topic, differentiation and integration. These two topics we have to cover in next 2 hours. So 1 hour differentiation, 1 hour integration. Okay. 11:30 it will be over. 11:30 it will be over. Those recently joined can stay and complete the calculus part. Vector part you have missed. Vector part is gone, but you still have chance to learn differentiation and the integration, which we could not complete in the last lecture. Last time I could not cover this part, but I'll complete now it. When will the session will get over? 11:30. 11:30 will be, it will be over. So does this mean particle starts moving in the opposite direction? No. No, 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 no. Change in the velocity is in that direction. So you can say, average acceleration is change in velocity vector divided by delta t. That will be the direction of the average acceleration. Particle is not moving in that direction. That will be the direction of the average acceleration. So average acceleration is in that direction only. Integration bada? Nahi, no. So let's start the differentiation. Differentiation is also called the derivative. Differentiation is also called as derivative. How do we represent the differentiation? So suppose there is a function, y is function of x. This is given. So we say find dy by dx. This is derivative of y with respect to x. This is called derivative of y, a differentiation of y with respect to x. So ये जो नीचे होता है ना, this thing, we are differentiating with respect to this. We are differentiating this function with respect to x, or we call it dfx over dx. So again, same derivative of fx with respect to x. So basically, this y is function of x. So when you change the x, y will change. So we are basically calculating the change in y with change in the x. There are two terms. One is called the finite change. Finite change. We represent that with delta x or delta y. When change is very small, infinitely small change is there, we represent that change as dx or dy. So when you change x slightly, a very small change in the x, corresponding to that change in the x, there will be change in the y. So we are comparing that change. So we are comparing the change of y with the change of x. This is called the derivative. Okay? Yeah, differentiation. What we are doing here? We are y is a function of x. So y depends on x. So if you change the value of x, value of y changes. Okay? If they are somewhere related. So slight change in x. What is the change in y? That change in y divided by change in x is the differentiation or derivative of y with respect to x. Delta x and delta y are the generally finite change. Matlab big changes are represented with the delta, and when very small changes are represented with dx. Sometimes dy by dx, or we write it like y dash, or we write it like df over dx, or we write it like f dash x. These all are derivative of y or f with respect to x. These all are called the derivative of differentiation of y with respect to x. These are all the way to ask a question of the differentiation. Whether they will ask find dy by dx, or they will say find y dash, or they will say find df over dx, or they might say find f dash x. This way they can ask the question of the differentiation. So these all are the terms which are used for the differentiation. And how do we call it? dy by dx, this is the derivative of y with respect to x, or differentiation of y with respect to x. df over dx, derivative of fx with respect to x. So whatever is written here, we are differentiating with respect to that. So what we are differentiating with? We are differentiating with respect to this term. So if I write, let's say position is given as function of time. Position is given as function of time. X is generally, x represent position, t represent time. So if I say dx by dt, so this is the derivative or differentiation of x with respect to t. Okay, so if this variable changes, then we say differentiation we are doing with respect to that variable. So it always, it will not be x in the denominator. It might be time, it might be anything else. So that is the differentiation of the x with respect to time. If we write dy by dx, that is the differentiation of y with respect to time. So are you getting this point? So whenever y is function of x, we are differentiating it with respect to x. We are comparing the change in the value of y by a small change in the value of x. Similarly, when x is dependent on the time, we are comparing the change in x with a small change in the time. This is the differentiation. Differentiation is this. Okay? Yes, only this part was the theoretical. This I have already covered. Now we are going to talk about the formulas of the differentiation. So before the sum rule, in the previous slide, I have unnecessarily talked about so many theoretical concepts. We don't have to cover them. So all the formulas of differentiation, formulas of differentiation. We can derive also these formulas, but there is no use. For the students preparing for the JEE, I usually derive these formulas. So if there is a constant function, means that function does not depend on the x. The rate of change of that function will be 0. So differentiation of the constant function is equal to 0. Differentiation of the constant function is equal to 0. There is a power rule. If there is a power of x to the power n, there is this kind of function. So differentiation of this will be equal to x n into x to the power n minus 1. Okay, n into x to the power n minus 1. N into x to the power n minus 1. Third one is, if a constant is multiplied to x to the power n, then constant will be out and it comes out to be n into x to the power n minus 1. Fourth formula is differentiation of the sin x over dx. Differentiation of the sin x is cos x. Fifth formula is differentiation of the cos x over dx. The differentiation of the cos x is minus sin x. Differentiation of the ln x over dx, that will be 1 upon x, and differentiation of the e to the power x over dx, that will be e to the power x. So these are the main formulas which we have to remember, and let's solve some numerical on this. Okay, then it will be easy to remember. These are the, how many formulas are there? 7. E galat ho gaya. 6. This is 7. So e to the power x, differentiation of the e to the power x will be e to the power x, ln x का differentiation 1 upon x, cos x minus sin x का differentiation cos x, c into e to x to the power n is c into n into x to the power n minus 1. So before starting the sum rule of the differentiation, let's solve some numerical on this. Let's practice some questions on this. Let's practice some questions on this. Okay. So question number 1 is y equal to x cube. Find dy by dx. Y equal to 1 upon root x. Find dy by dx. Y equal to root x. Find dy by dx. Can you find dy by dx in all these three cases? And other cases are on the way. Y equal to 3x square. Find dy by dx. Y equal to 3 divided by x square. Find dy by dx. Y equal to can you find all these differentiation? Can you solve these differentiations? These are the basic differentiations with the basic formulas, and I hope you will be able to solve it. Can you solve this? What will be the dy by dx? So this can be compared with x to the power n. What is the value of n here? Value of n is 3. Value of n is 3. So when we are doing this differentiation dx to the power n by dx, what is the differentiation of this? N comes, n बाहर आएगा और x की power n minus 1. So 3 into x to the power 3 minus 1. So differentiation will be 3x square. Got it? Got it? This will be the differentiation of the first one. Differentiation of the first one is clear to all of you. How do we solve this question? Can I write this as x to the power minus 1 by 2? Can I write like this? Say yes, sir. So dy by dx, this power comes out minus 1 by 2 x to the power minus 1 by 2 minus 1. This is minus 1 by 2 x to the power minus 3 by 2. It will be minus 1 upon 2 x to the power 3 by 2. This will be the answer. Minus 1 by 2 x to the power 3 by 2. Is this clear? So this is root x, means x to the power 1 by 2. So we take this up, x to the power minus 1 by 2. So n is equal to minus 1 by 2. When we differentiate, this minus 1 by 2 will be out, and x to the power minus 1 by 2 minus 1. So this is minus 3 by 2. So we take this down, x to the power 3 by 2. Clear? Clear, 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 clear. A clear, a clear. Okay. We can write this like x to the power 1 by 2. So what is the n here? Value of n is 1 by 2. So when you differentiate it, 1 by 2 will be out, x to the power 1 by 2 minus 1. So 1 by 2, x to the power minus 1 by 2, it will be 1 upon 2 root x. This will be the answer. Okay, 1 by 2 root x will be the answer of this question. This behave like n, this behave like constant. So constant will be out, n will be out, x to the power 2 minus 1. So this will be 6x. Done? These are the differentiation at a good speed. Can I write this 3 into x to the power minus 2? So when we differentiate, 3 is the constant, it will come out. Power will come out and power will be minus 2 minus 1. It will be minus 6 divided by x to the power 3. dy by dx is equal to minus 6 divided by x to the power 3. I can write this 1 upon 2 x to the power minus 1 upon 2. When I differentiate, 1 upon 2 is a constant, it will come out. And this power will come out. X to the power minus 1 by 2 minus 1. So x to the power minus ka 3 by 2. So it will be minus 1 divided by 4. X to the power 3 by 2. This will be the answer. Minus 1 divided by 4 x to the power 3 by 2. These are the basic differentiation. Okay. So the formulas I have just covered, based on those formulas, these are the basic differentiation. Are these differentiation clear to all of you? Differentiations clear to all of you, or you are doing panchayat in the chat box? Okay, so let's move to the sum rule of differentiation. What is this rule? So when there are two functions, u which is a function of x plus or minus v which is also function of x, when we want to do the differentiation of these dy by dx, so we have to just do differentiation of u with respect to x, differentiation of v with respect to x. We don't have to worry about it. This is a very simple rule. For example, let's solve some questions. So y equal to root x plus 1 over root x, not this kind of question, otherwise you will start crying. X to the power 4 plus 4x minus plus 1. So what will be the differentiation dy by dx? What will be the differentiation of this? Example number 2, y equal to cos x minus 2 sin x plus e to the power x. What will be dy by dx? Can you solve this first question? Can you solve these two questions? Can you solve these two questions? Sum rule of differentiation. Based on the sum rule of differentiation, there are two questions given to you. Please don't forget to like this session, subscribe the YouTube channel where you are getting one of the most useful series of 75 days where all the faculties of this channel are dedicatedly working to fulfill the commitment they have made. All are doing their work, all the faculties are doing hard work and with full on dedication. So the answer of this question will be, the power will come out and there will be 4 minus 1, so x to the power 3. Here this is constant 4, x to the power 1, so 1 will come out and power x to the power 1 minus 1 will be 0. So x to the power 0 will be 1 and the differentiation of 1 will be 0. So this will be the answer. When you are differentiating this, cos x differentiation will be minus sin x differentiation will be cos x, and e to the power x will be e to the power x, and this will be the answer. So this was very, very easy. Did you find it very easy or very difficult? Very easy. There is nothing in this. This is the super easy concept. Some rule of the differentiation is the super easy concept. Okay. So let's move to the other rule, that is the product rule of the differentiation. What does this rule say? So when a function y is given like you multiply ux with vx, there are two functions which are multiplied with each other. So differentiation of y with respect to x will be, so you differentiate one function at a time and multiply the other function. So let's say I differentiated v, so u into dv over dx plus ka. Now v will remain same and we will differentiate u. So one at a time we differentiate. So we call it like y dash is equal to u into v dash plus v into u dash. This is the differentiation using the product rule. So we differentiate one function at a time, multiply with the other function, plus now we differentiate the other function and multiply with the first function which we have already differentiated. This is very simple rule, very, very, very simple rule. So let's solve some numerical on this rule as well. So we are going to solve some questions. Question number 1 is y equal to x into e to the power x. Can you differentiate it? Find the dy by dx. Okay, this is one question. I am going to give you so many questions on this. Question number 2. Y equal to e to the power x into sin x. Find dy by dx. Question number 3. Y equal to x square minus x cos x. Find dy by dx. Okay, there are. Question number 4. Y equal to x into ln x. Find dy by dx. See, there are 4 questions given to you. Let's see how many of you are able to solve these questions. How many of you are able to solve these 4 questions? Let's see. How many of you will be able to solve these questions? These 4 questions are waiting for you. And you are waiting for fight. So there is no match for you and your fight. So please solve these questions. Can you solve this question? So student, what we will do is, we treat this function as u, this function as v. So we differentiate first x, so differentiation of x will be 1. We multiply with ex. Now x we leave just like that and we differentiate e to the power x. Now e to the power x we take common and 1 plus x is the answer. Differentiation of this is e to the power x 1 plus x. Let's differentiate this. So differentiation of e to the power x will be e to the power x into sin x plus. Now e to the power x will remain same and differentiation of sin x will be cos x. So the answer will be equal to e to the power x sin x plus cos x. This is the answer of these two questions. Now we are going to consider this as u and this as v. So first we differentiate this. So differentiation of this will apply the sum rule. So differentiation of this will be 2x, or differentiation of x is 1. So we have already differentiated this thing. We multiply with cos x. We don't differentiate it. Plus, now we leave this x square minus x and we differentiate this, which is minus sin x. This will be the answer of this question. We can take out this minus here and will be the answer. Okay. Are these all the questions clear to you? Let's talk about this. Y equal to x into ln x. This is first function, this is second function. We differentiate this x, the differentiation will be 1 multiplied by ln x plus x will be here. Differentiation of ln x will be 1 upon x. It comes out to be 1 plus ln x. This is the differentiation of x into ln x. Differentiation of x will be x into ln x plus x into 1 upon x. That will be 1 plus ln x. These are the differentiations of. This is the product rule. Is this clear to all of you? Clear? Not clear. Clear? Not clear. Clear? Not clear. The differentiation is, product rule of differentiation is done. Integration I am about to start, but let me finish the differentiation part. Oh, product rule of differentiation done. Okay, this is done. There is a quotient rule of the differentiation. When a function yx is given like ux over vx, then differentiation of y with respect to x is given as, first we differentiate ux over dx minus, now we differentiate vx over dx divided by vx ka whole square. So we write it like this: y dash is equal to u dash into v minus v dash into u divided by v square. This is the quotient rule of differentiation. Quotient rule of differentiation is this. Let's solve some numerical on this. The quotient rule of the differentiation. So question number 1 is y equal to tan x. Find dy by dx. So you can write tan x like sin x upon cos x. Okay, then differentiate it using the quotient rule. You get the differentiation of the tan x. Question number 2 is y equal to sec x. Find dy by dx. Then you have to find dy by dx. So y equal to tan x, which is sin x upon cos x. Y equal to sec x. Find dy by dx in both the cases. So here I can consider sin x as u, cos x as v. First we differentiate u. So differentiation of sin x will be cos x. We multiplied with v. This will be cos x. Minus. Now sin x will remain same. We differentiate v. Cos x differentiation will be minus sin x. We divide with cos x whole square. So dy by dx comes out to be cos square x plus sin square x divided by cos square x. So it is sec square x. So differentiation of tan x is sec square x. You have to remember this. Differentiation of tan x is sec square x. And differentiation of cot x, I am just writing direct formula. Differentiation of cot x over dx is minus cosec square x. Here I am writing the formula of tan x. D over tan x over dx is the sec square x. Okay, keep these two formulas in mind. This and these two formulas are very important. Okay, now we are differentiating sec x. So y equal to sec x can be written like 1 upon cos x. We are treating this as a v, 1 as a u. So dy by dx will be equal to, first we differentiate 1, that will be 0. We multiply with denominator cos x minus. Now we multiply with 1 and we differentiate cos x, which will be minus sin x. And this divided by cos square x. So it comes out to be d of sec x over dx is equal to sec x into tan x. And differentiation of cosec x over dx is equal to minus cosec x into cot x. Okay, these are the two more formulas which you have to remember. These are the application of quotient rule of differentiation. These are the applications of the quotient rule of differentiation. Is this clear to all of you? All the formulas are clear. Differentiation, quotient rule, product rule. We can solve some more problems on this. So, few more problems. Question number, how many we have solved? 2, 3. Y equal to x square minus x divided by sin x. Find dy over dx. Solve this question. Question number 3. Question number 4. Y equal to e to the power x ln x divided by cos x. Find dy over dx. This is the maximum difficulty level of this part of the differentiation. Maximum difficulty level. So, how do we solve this question? This we treat like ux, this we treat like vx. Okay, I'm trying to finish this topic as soon as possible so that we are moving to the application part, which is way too important, and then to the integration part. That is also quite important, and the substitution rules and all I'll teach in the integration. And this basic differentiations, but I want to get over as early as possible. Okay, so differentiate numerator, multiply with the denominator. So numerator differentiation will be 2x minus 1. We multiply with denominator minus. Now numerator will remain same and the differentiation of the denominator will be multiplied. This comes out to be sin square x. So dy by dx of this will be equal to 2x minus 1 sin x minus x square minus x into cos x divided by sin square x. Here this whole term is treated like u and this like v. So we differentiate first u. So while differentiating u, we have to apply the product rule. So the differentiation of the upper part will be first differentiate e to the power x, ln x remains same, plus now e to the power x remains same, ln x, differentiation of ln x will be 1 upon x. So the differentiation of this is this. You multiply with cos x minus. Now this part remains same, e to the power x into ln x, and differentiation of the cos x will be minus sin x. Multiply with minus sin x, divide by cos square x. This will be the answer of this question. The answer of second question will be this. So these are the maximum difficulty level, or you could say even this level of questions will not be asked in your exam. But I just wanted you to practice these. So both the product rule and the question rule I am writing one more time. D of u into v over dx is written like u dash into v plus v dash into u. Okay, this is product rule, and question rule is d of u over v dx is equal to u dash v minus v dash u divided by v square. These are the two formulas, very important formulas. Just identify u and v and you will be able to solve both the questions. Got it? So this is the question rule of the differentiation. Now there is a question number, the number I forgot to change. Okay, so y is function of x given y equal to x ki power 3 plus 2x plus 1, then dy by dx at x equal to 1 will be. We will take a small break in between and then we will start the class again. Okay, let's take a small break of how many minutes? 15 minutes. We start the class. So it's 10:05 and 10:20. We finish the chapter after that. Okay, so you take a small break because and please stop this nonsense in the chat box. Don't do this. Bullying each other is not allowed in these classes. So we meet after 15 minutes and we start the remaining part of the differentiation, that is the chain rule and the application part, and then integration, and we are done for the today. Okay. Okay. See you all in at 10:20 after 15 minutes. इंटीग्रेशन जो है करीब करीब 20 मिनट और लगेंगे उसके बाद ना, 10:20 के बाद 11:15 स्टार्ट हो जाएगा. Hello guys, I'm back 1 minute early. So let's finish this chapter in one shot. And now I'm going to start a very important topic, and that is the chain rule of the differentiation. This is the most difficult part of the differentiation. So don't keep yourself busy in this chatting and all. Try to focus on learning this concept. If you are aiming the aims daily, then your aim should be on this board. Like, you should be focusing on this board, not in the chat box. Okay, so don't unnecessary chat in the box. And sometimes I am not able to understand what you are typing and all, so please avoid the chatting. And if something is necessary and something you want to ask, then directly ask me in English. So even I should be able to, I should be able to the part of that chat. Okay, so this path is not that easy. So you have to work hard and work smart as well. And we are trying our best to make that happen. You should be able to achieve your goals or whatever dreams you have seen. Like, you should be able to achieve them. So we are trying our best. You should try your best, and then only things will be in your favor. Your result will be in your favor. Whatever you are planning, whatever college you want to go join, that will be possible only if you work hard and do not get involved in the unnecessary chit chat with the others. Okay, is this clear to all of you? You all are very serious student, and you are already doing good. So please do not waste your time. There will be somebody who will always try to provoke you, but you don't have to entertain them. Got it? So let's start the session again. So this was the question which was given to you. The function is given y equal to x to the power 3 plus 2x plus 1. Then find the dy by dx at x equal to 1. So you have to find the dy by dx at x equal to 1. When value of x is 1, you have to find the value of dy by dx. So this is a very easy question, not a difficult one. This is a very easy question. We first find dy by dx. So dy by dx will be, there is x to the power 3. So 3 will come out and it will be x to the power 2 plus 2x. The differentiation of 2x will be 2. Differentiation of 1 will be 0. Now we have to find dy by dx at x equal to 1. So what we do is we put value of x equal to 1. So 3 into 1 to the power 2 into 2. This comes out to be 5, and 5 will be the answer of this question. D option will be the correct option. So D option, yes, you all were right. Yes, you already told the answer, and the 5 is the correct answer. Okay, so this is the correct answer. So I was talking about this, the chain rule of the differentiation. This is very, very difficult and very important part of the differentiation. Most of the teachers skip this part because they say this will not be asked, but there are believe me, there are the questions in your physics syllabus which cannot be solved if you don't learn this method, which is the chain rule of the differentiation. Why is this so difficult? Basically, there are multiple functions involved. Let's call it, suppose there is a function written like this, f of g of x. So these functions are called composite functions. These functions are called composite functions. So when you differentiate this function, what you do is you first differentiate f with respect to this inner function, and then you multiply the differentiation of the inside function with respect to x, and this way we differentiate this kind of functions. So this might not be clear to you because with the help of the formula we cannot understand the chain rule. We will solve some numericals and then we will be able to understand. So there will be 2 functions or 3 functions One will be outside, the other will be inside that, and the if third function is there, that will be inside the second one. So let's solve some new illustration on this. So example 1. Let's say there is a function y equal to sine x square. So this is a function y equal to sine x square. This is totally different from y equal to sine x. Y equal to sine x is a simple function, but y equal to sine x square is a different function. So can you tell me which is the outside function? Sine is the outside function, and inside the sine there is x square. So this is the inside function. So when you differentiate this dy by dx, you first differentiate outside function, keeping the inside function same. What will be the differentiation of sine? The differentiation of the sine will be cos, and inside function remains same. Okay, this is done. Now you multiply the differentiation of the inside function, and that is the x square. The differentiation of the x square is equal to 2x. So final differentiation will be like this. So this will be the differentiation of this function sin x square. This is the differentiation of the sin x square. Is that clear to all of you? So you have to identify the angle of sine is x square. So which is the outside function? Sine. Which is the inside function? X square. So first differentiate outside function, keeping inside same, and then differentiate inside function and multiply that with the first part of the differentiation. Okay, this way we solve the chain rule of the differentiation. So this is just one example. We are going to solve so many examples on this. Then I hope this will be clear to all of you. So let's say example 2. There is y equal to sine square x. Find dy by dx. Find dy by dx. If y equal to sine square x is given, then how do you find dy by dx? How do you find dy by dx? So students, what we will do is we will write it like this: sine x whole square. Can I write this like this? You say yes, sir, you can write it. Now differentiate it. Which is the outside function? That is this power. This is the outside function. So what we will do is we will apply the power rule. 2 will come out, inside will remain same, and power will become 2 minus 1. This is the power rule. Now we differentiate the inside function and we multiply it outside. So differentiation of the sin x will be cos x. Differentiation of the sin x will be cos x. Now we get differentiation of that function dy by dx is equal to 2 sin x into cos x, and this is equal to sin 2x. This will be the differentiation of the sin square x. Is this clear to all of you? Yes, sin 2x will be the differentiation of the sin square x. Let's solve one more problem. Example 3. Y equal to sin 2x. How do we solve this question? Find dy by dx. Find dy by dx. How do we solve this question? How do we solve this question? So to solve this question, we identify the outside function. This is the inside function. So dy by dx will be, first differentiate the outside function, which is the sin x, and inside remains same. Okay, we have differentiated this, differentiated sin x, and inside function we did not change. Now differentiate inside function and multiply outside. So this is also known as inside outside rule. We first differentiate this outside function with respect to inside function, and then we differentiate the inside function and multiply it outside. So now the differentiation of 2x will be 2. So the answer will be 2 cos 2x. If anything is not clear to you, please let me know so that I can repeat that concept. These are the 3 simple examples of the chain rule of the differentiation. We are going to solve few more questions we are going to solve. No, it will not be cos 4x, it will be 2 times cos 2x. Actually, this 2x is the angle of cos. So you cannot multiply 2 with the 2. Okay? Is this clear to all of you? This is the chain rule of the differentiation. Let's solve few more problems. Question number 4. Y equal to ln x square minus x. Find dy by dx. Question number 5. Y equal to e to the power x square plus sin x. Find dy by dx. Question number 6. Y equal to e to the power sin x. Find dy by dx. Question number 7. Y equal to x square minus x to the power 3. Find dy by dx. These are the few questions which we have to solve before moving ahead. So y equal to ln x square minus x. And we have to find dy by dx. So which is the outside function? Ln. And inside is this. How do we differentiate ln? So whatever is inside ln, it will go down. Inside the ln is this, it will go down. So first we differentiate this. So inside of ln will go down. Okay. Then we multiply the differentiation of the inside, which will be 2x minus 1. This will be the answer. This will be the answer. So final answer will be 2x minus 1 divided by x square minus x. This will be the final answer. Got it? So whatever is inside ln, it will go down, and then we differentiate inside function and multiply outside. Same thing I am doing for all the differentiation. We first differentiate outside function, we keep the inside of that outside function same, and then we differentiate the inside of the function and we multiply it outside. Got it correct? Okay. How do we solve this differentiation? E to the power x. So differentiation of e to the power x is the e to the power x. So when we differentiate this outside function, it remains same, x square plus sin x. It will remain same. Okay. Now we multiply. This thing is multiplied. This thing is multiplied with differentiation of this part, which is 2x plus cos x. So differentiation of this is this. Differentiation of the e to the power sin x. Differentiation of the e to the power sin x. We first differentiate e to the power, that comes out to be e to the power sin x, and we multiplied with the differentiation of the sin x, that is the cos x. This will be the answer. So dy by dx will be e to the power sin x into cos x. Done. We are differentiating this. First we will differentiate this power. So dy by dx dy by dx will be equal to, power will come out 3 into x square minus x to the power 2. Now we differentiate inside of the function, which is 2x minus 1. This will be the answer. So these are the few chain rule applications. 2 is missing here, na? Like I wrote, but somehow there is some problem with this smartboard. So these are the chain rule of the differentiation. Chain rule of the differentiation. These are the more than sufficient illustration on the chain rule. Okay, got it? Let's talk about the applications of the differentiation. Applications of the differentiation. What are the applications of the differentiation? So what the applications which we use in the physics? Number 1 is velocity is equal to dx divided by dt, where x is the position of particle. So whenever position of the particle is given as function of time, x is given as function of time, by differentiating position you can find the velocity of the particle. Acceleration is equal to dv by dt, or this is equal to d2x by dt square. Either you differentiate position 2 times or you differentiate velocity 1 time, you get the acceleration. So v is the velocity. This is called the double differentiation, and x is the position, and t is the time. So there are these two very important formulas. One is v equal to dx by dt, and the other is a equal to dv by dt. There is one more formula of the acceleration, that is called v into dv divided by dx. So if velocity is given as function of x, then use this formula. If velocity is given as function of x, then use the formula a equal to v into dv divided by dx to find the acceleration. If velocity is given as function of time, then use this formula. If position is given as function of time, then use this formula. So there are these 3 very important formulas. There is one more formula of the force, net force on a particle is equal to dp vector divided by dt. So p is the linear momentum. P is the linear momentum. So rate of change of linear momentum gives you net force acting on the particle. So linear momentum, rate of change of linear momentum is the force. V dv by dx is the acceleration. dv by dt is the acceleration. dx by dt is this. There is one more important formula. Current is equal to dq divided by dt. This is also very important. And q is called the charge. Rate of charge flow is called the current. These are the few application of the differentiation in the physics. These are just few application out of so many applications. So these formulas will be required in the beginning of the next chapter, that is the kinematics. That's why I have covered these formulas here. Clear? Yes. V equal to dx by dt, a equal to dv by dt, a equal to v into dv by dx. These are all the formulas. So there is one question on that. If position of the particle moving along the x-axis is given as a function of time, x to the power 3 minus 2t, then find the velocity of the particle at t equal to 2 seconds. So their position as a function of time is given, and they are asking the velocity of the particle at t equal to 2 seconds. This is very easy question. Please answer this question. This is very easy question. Like this type of question also we will cover in the kinematics as well. What will be the answer of this question? What will be the answer of this question? Answer to this question. So dx by dt is the velocity and x is given as t to the power 3 minus 2t. So dx by dt velocity is 3t square minus 2. We put value of t equal to 2 seconds. This comes out to be 3 into 2 to the power square minus 2. 10 meter per second will be the answer. So 10 meter per second is the answer of this question. Then the velocity of the particle at t equal to 2 seconds will be 10 meter per second. 10 meter per second will be the answer. Got it? Clear to all of you? There is another application of the differentiation that is called the slope of any curve. So if we have any curve, and the slope of that curve we have to find. So let's say there is a curve like this. This is y axis, this is the x axis. So there will be function of y will be function of x will be given. So at any point, if we are interested in the slope of tangent, this is called tangent. This point is A. Tangent at point A. So slope of this curve is given by two ways. The slope at this point, if this angle theta is known to you, then slope of curve at A is equal to tan theta, and theta is angle made by tangent with x axis. Okay, so slope we can find with the help of theta if theta is known, otherwise if theta is not known. So slope at A is given by dy by dx. So dy by dx is the whether you differentiate y with respect to x, you get the slope of this curve at this point at any x. You put the value of x and y, you get the slope at A. So whenever you have to find the slope of any curve at any point, it will be equal to dy by dx. So what will be the slope at this point? So slope of this point will be 0. Slope at this point will be 0. So dy by dx at this point will be 0. So whenever there is a maxima or minima, see at this point as well, what will be the slope here? Here also slope will be equal to 0, means dy by dx will be 0 here. So whenever there is like maxima or minima, the slope of the curve will be 0, or you say dy by dx at that point will be 0. So slope will be 0, dy by dx will be 0. See, velocity is dx by dt. So slope of x versus t gives us velocity. Okay, keep this thing in mind. Slope of x versus t gives us velocity. If acceleration is dv divided by dt, slope of v versus t gives us acceleration. So if velocity time graph is given, then the slope of that will give you acceleration. If position time graph is given, then the slope of that position time graph will give you velocity. Got it? All clear to you up to this part? Slope of the curve, application in the physics, which are this slope wala application. So slope we have to find, if we want to find a slope at any point, it is equal to dy by dx. Velocity is dx by dt, so slope of x versus t will give us velocity. A is dv by dt, so velocity times slope will give us the acceleration. So let us say if this curve is velocity versus time, here slope will be positive. So dx by dt will be positive. Here dx by dt will be 0. Sorry, dv by dt will be 0. Here acceleration will be 0. Again acceleration will be negative. Acceleration 0. Now again slope is positive. Then acceleration will be positive. If this curve represents the x versus t, position versus time curve, then velocity is positive, 0. Negative velocity, 0. Again positive velocity. So slope will give you position versus time curve, slope will give you velocity. Velocity versus time curve slope will give you acceleration. So with the help of the slope only we can find the velocity and the acceleration if x versus time curve is given or v versus time curve is given. And slope is equal to, if y versus x is given, then slope is given by dy by dx. So here there is a question. Magnitude of the slope of the shown graph. What will happen to the magnitude of the slope? Magnitude. They are asking the magnitude of this slope. This curve is given like this. Y versus x is given. What will happen to the magnitude of the slope of this curve? What will happen to the magnitude of the slope of this curve? They are saying first increases and then decreases. First decreases and then increases. Increases, decreases. What will happen to the magnitude of the slope? Who will answer this question? What will happen to the magnitude of this? Magnitude of the slope of this curve. Magnitude of the slope of this curve. Okay. So here the slope is negative, but the magnitude will be positive. So the slope, and here the slope is 0. So from negative to it reduced, the magnitude is decreasing and then it becomes 0. Magnitude is decreasing. If you say slope, so slope will be increasing actually, like the magnitude we can say, here magnitude is maximum, then it becomes 0 and then it start increasing. Slope here will be positive, it start increasing. So first decreases and then increases. So first decreases and then increases. B option will be the correct option. So now you are able to find the slope of any curve. You are able to answer the questions related to the slope. Let's move to the next concept. Instantaneous rate of change. Okay. Suppose a quantity x is function of time. So if we change time, x will change. X is the function of time. So we want to find the rate of change of x with respect to time. So we write dx by dt. This is called a rate of change of x with respect to time. What is dx by dt is called? Rate of change of x with respect to time. If I write dy by dt, this is a rate of change of y with respect to time. So this is called the rate of change. So dx by dt या dy by dt gives us the rate of change of x, rate of change of y with respect to time. These are called the rate of change. Rate of change. This is also known as the rate of change. So differentiation, whenever we have to find rate of change, we write like this: dx by dt, dy by dt. Okay. Got it? So rate of change is written like this. There is a question. Water pours out of at a rate of q, meter cube per second. This is the rate at which volume is coming out from a tap into a cylindrical vessel of radius r. The rate at which the height of the water level rises when the height is h is. So we have to find, like, at a point the height of the water level in the container is h, and what is the rate of level rise in that container, that we have to find. We are given q meter cube per second water is coming into that vessel of radius r. So this is a question of the rate of change. So let's try to solve this question. So there is a cylindrical container. Okay. There is a cylindrical container. Let's say at any moment the height is h, the base radius is r. Okay, height is h, base radius is r. So volume of this part V will be pi r square into h. This will be the volume which is stored in this. Now we are pouring the water into it at a rate of q. So q is basically dV by dt, rate of change of volume. Basically the rate at which volume is being added is given. So volume will be changing. What is the rate of change of that volume change? Or what is the rate of change of volume? Because volume is changing. So the rate at which you are pouring the volume is the rate of change of the volume. So this volume is given as a function of r and h. Okay, the function of r and h, it is given. R is constant, r is not changing, base radius is not changing. When you add the water or liquid, whatever is there, the height will rise, so height will be changing. This is changing, this is changing, so we differentiate it with respect to time. So this will be dV by dt, this will be pi r square into dh divided by dt. This is the rate at which you are adding the volume q. This is pi r square, and this is the rate at which level is changing, rate of level change. So the height is increasing at this rate, rate of level change. This they are asking, dh by dt. So dh by dt comes out to be q divided by pi r square. This will be the answer of this question. So dh by dt will be equal to this will be the dh by dt q divided by pi r square, and this second option will be the correct option. Got it? How do we solve this question? So we find the function of the volume. We found the function of the volume as a function of R and H. R is constant, but H is changing because V is changing. We know at what rate V is changing. V is changing at the same rate which rate we are pouring the water into the container. So dV by dt, the rate of change of the volume, this V is the volume. So the rate at which you are adding the volume is dV by dt, which is equal to Q, which is equal to pi r square dH by dt. dH by dt is the rate of change of the rate of level change. So that we have to find the rate at which level is rising. That dH by dt, height will be changing, na? So dH by dt will be rate at which level is rising. So dH by dt comes out to be Q divided by pi r square. And this is the answer. Slightly difficult question, but again not out of syllabus. Slightly difficult. This is easy question, okay? If the radius of a circle is changing at a rate of 1 centimeter per second, then find the rate of change of the area of the circle when its radius is 10 centimeter. You can solve this question. You all can solve this question. If the radius of a circle is changing at a rate of 1 centimeter per second, then find the rate of change of the area of the circle when its radius is 10 centimeter. Will you try this question? I hope after this there is one more application of the differentiation, and then we start the integration part. Integration part we will be able to start by 11:05. 11:05 we will start the integration. Today is very it's first time I am taking this long class, like it's almost 6 hours, and one more hour it will take, approximately 7 hour long class. This is first time I have done, and it was very interesting. Like, you people are continuously watching the class. That is the motivation behind this energy level. I'm not tired yet. Like, I can continue the class for next 2 hours, but anyways, why to waste the time, and we can finish it in the next 1 hour. Okay. The radius of a circle is changing at a rate of, so let's solve this question. So there is a circle, and the radius of this circle, let's call it R. So what is the relation between area and the radius of the circle? Area is equal to pi r square. This is the relation between them. And this R is changing. This is changing with time. So this will change. This will change, because radius is changing. So how do they are related with each other? So dA by dt, if I differentiate this, pi is constant, this will come out. We are differentiating with respect to time. So we write differentiation of this will be 2 will come out, power to the r will be 1, and you multiply with dr by dt. Don't forget to multiply with it. If you are differentiating any other variable with respect to some other variable, then always write this. So dr by dt, this is given, radius is given 10 centimeter, dr by dt is given 1 centimeter per second, and they are asking dA by dt, what rate at which area is increasing. So that will be 10 pi centimeter square per second. So we put dr by dt equal to 1, r equal to 20 pi. So 20 pi centimeter square per second will be the rate of change of area. So rate of change of area will be 20 pi centimeter square per second. So this is the one more question on the differentiation. Done? Is this clear to all of you? So whenever there is a one parameter which is related to other parameter, and that one parameter is changing, then other will also be changing, then you differentiate both and you get the relation between them. A equal to pi r square, differentiation of this will be dA by dt equal to pi 2r dr by dt. Let's move to the application of the differentiation. One more application of the differentiation, that is the maxima and minima of the function. This is the very important application and the last application of the differentiation. After this, we start the integration. So let's say there is a y is given as a function of x. Y is given as function of x. It is given. Okay, it is given. So graph is like that. So this is called maxima. This is called minima. Again maxima. Again minima. Okay, maxima and minima. These are called the local maxima and minima. These are not called the global. These are the local maxima and minima. Local means in their vicinity they are at the maxima or they are at the minima. Value at this point for this x, value of y is maximum in its close neighborhood. Value of y at this point is minimum in its vicinity or close neighborhood. Same for this. One thing is clear here. Slope of this curve will be 0 at this point. Slope will be 0. Even here, slope will be equal to 0. Even here, slope equal to 0. Same for this point, slope equal to 0. So at all the maxima and minima point, slope will be equal to 0. Slope will be equal to 0 at all the maxima and minima points. So whenever we have to find the maxima or minima and the function is given to us, y is given as a function of x, then first step 1 is find dy by dx. Find this. Okay. Second step is find d2y by dx squared, double differentiation of y. And third step is find dy by dx equal to 0, all the solution of this equation. If let's say solution of this equation are x1, x2 and x3 and so on. Step 4 is check if d2y by dx square at x1 is greater than 0, then x1 is minima. If d2y by dx square at x2 is less than 0, then maxima at x2. These are the steps, 4 steps which we follow to find the maxima and minima. First, what we will do? We differentiate it one time. We differentiate y with respect to x for one time. Then we differentiate for one more time. Now we solve the first equation dy by dx. We put equal to 0. Then we solve. We get some solution for which the equation is satisfied. Then we put those solutions, values of those x1, x2 and x3 in double differentiation equation. If that comes out to be greater than 0 for any value, then at that x it will be minima, and if it comes out to be less than 0, then at that x it will be maxima. So this cannot be clear by seeing these steps. I'll explain this with the help of a question. So we solve a question and then I explain all these steps. Okay, so I'll explain all these steps through a question. There is this question. Particle's position as a function of time is given. X as a function of time we are given. What is given to us? X equal to minus t square plus 4t plus 4. Okay. Find the maximum value of the position coordinate of the particle. So they are asking the maximum value of this. So what we do? How do we solve this question? So what did I say? This is x as a function of time. Here it is not y as a function of x, it is the x as a function of time. So what we will do is, we will do dx by dt. What is dx by dt here? So we differentiate it, minus 2t plus ka 4. We double differentiate it, d2x by dt square. It comes out to be minus 2. Now we solve this equation. What we do is dx by dt equal to 0. What is dx by dt? Minus 2t plus 4 is equal to 0. So we get t equal to 2 second. So at t equal to 2 second, whether it will be minima or maxima? Minima or maxima? So it is maxima or minima. To check that, we check the value of double differentiation, d2x by dt square, which is equal to minus 2 for all value of t. So for t equal to 2, d2x by dt square is negative. So whenever double differentiation is negative for the solutions of this equation, there will be maxima. So x is maximum at t equal to 2. This will be the answer. X is maximum at t equal to 2. X is maximum at t equal to 2. So what is the maximum value of 2 at x? Maximum value of x is, we put t equal to 2 here, minus 4 plus 8 plus 4, and this comes out to be 8. 8 is the answer. So the C option is the correct option. This way we solve the maxima minima problem. Is there any problem? Any problem till here? Listen, I'm re-explaining it, okay? I'm repeating this case. Whenever we have to find the maxima and minima of a function, what we do is, first we differentiate that function. That we have done. So there was x as a function of time was given. So I have differentiated x with respect to time. We got minus 2t plus 4. Second step is double differentiation. I have done double differentiation of the x with respect to time and we got minus 2. Now we solve the first equation. We put dx by dt equal to 0. So minus 2t plus 4 I have put equal to 0. From there I got t equal to 2. So from this equation I know one thing. At t equal to 2, either it will be minima or maxima. Now to find it is maxima or minima, I have to put the value of t, which is 2, in the double differentiation equation. But double differentiation is constant for all the value of t. It is not variable. Double differentiation of x is minus 2. It is constant for all value. So it will be minus 2 for t equal to 2 as well. So double differentiation of x is minus 2 for all value of t. So for t equal to 2, double differentiation is negative. So whenever for any value of this equation, which is dx by dt equal to 0, for any value of this equation, if double differentiation is negative, then for that value, the function will be maximum at that point. So x is maximum at t equal to 2, and we put the value of t in that equation to find what is the maximum value of x, because find the maximum value of the position coordinate. Matlab we have to find the maximum value of the x, not the value of time. So time is the value of t, which is 2. It is the time when x is maximum. But what is the maximum value of x? That we will get if we put the value of t into that equation. So that equation, when we solve that equation, we find the x maximum is equal to 8. Is that clear to all of you? Clear now? Okay, let's forget about that question. Okay, let's move to this question. This one, next question. Determine the position where potential energy will be minimum. Again, one more question. So potential energy as a function of x is given. These questions are taken from the NEET module. This question is taken from the NEET module. So when you will be solving some any coaching module, you will find you will face this kind of questions. You have to you must be able to solve this kind of questions. These questions are not just taken from the JEE or JEE main syllabus. No, these are picked from the NEET module, or I hope Unacademy NEET module. I picked these questions from the Unacademy NEET module. Unacademy's basic maths module is there. From that module only I pick these questions. So you must be able to solve these questions because these are part of your syllabus. Okay, I'll explain this question as well now. I hope you will be able to understand after this. So after this we start the integration. See, you don't have to worry about it. What is given here? U as a function of x is given here. Okay, what is given? This is given. What they want to find is where the potential energy will be minimum or maximum. So where the potential energy will be minimum, they are interested in that. Okay, so first step is what? U is function of x, then du over dx you have to find. What is du over dx? So differentiation of 100 will be 0, that of this will be minus 50, that of this will be 2000 x. Okay, double differentiation of this, double differentiation will be 2000, which is positive for all the value of x. Double differentiation is positive for all value of x because it does not depend on x. See, the value does not depend on x, so double differentiation is always positive. Now third step is you make this value equal to 0. From here you solve it. Minus 50 plus 2000 x. The value of x comes out to be 1 by 40. Value of x comes out to be 1 by 40. At this value, there is a either maxima or minima. See, keep one thing in mind. This is the slope of u versus x. Can you say, if I say at a point slope is 0, will it be maxima or minima? You cannot say anything. See, at maxima or minima, at both places, the slope is 0. Here slope is 0, here slope is 0. This is minima, this is maxima. So by doing this, you cannot say कि at x equal to 1 by 40, it will be maxima or minima. But you know that either here it will be minima or maxima. Now you put this value into double differentiation. So double differentiation is independent of x and it is always positive. So this will be positive for this value as well. So whenever double differentiation is positive, what do you get? Minima. So double differentiation is du over dx square is positive. So at x equal to 1 by 40, it will be minima. So u will be minimum at x equal to 1 by 40. So you put that value in this. So u at x 1 by 40 will be equal to 100 minus 50 divided by 40, 5 by 4 plus 1000 divided by 1600. You solve this question, you get the minimum value of the u. You will get the. Is it clear now? So there are two steps every time you will be following. One will be you will differentiate the equation equal to double differentiation, one differentiation, double differentiation. Then you equal to you make this, you solve this equation for 0. You are finding those points where the slope is 0, so that you can identify those points where maxima or minima is lying. And now you have to identify at which point there will be maxima, there will be minima. So you check double differentiation, because at double differentiation point, see, this is the maxima. Here slope is positive, here slope is 0, and here slope is negative. So double differentiation is the rate of change of slope. So initially it was positive, then 0, then negative. So rate of change of slope will be negative here. So whenever there is a maxima, double differentiation will be negative. So by doing this step just gives you the points where slope is 0, but you will not be able to identify whether it is a maxima or minima. To identify whether it is a maxima or minima, you solve this equation, you find those points where the slope is 0, and now you put those points into double differentiation. If double differentiation at any point comes out to be greater than 0, then that point is minima point. And double differentiation at any point comes out to be less than 0, then that point is the maxima point. So minima and maxima are defined like this, and this is the application of the differentiation. Differentiation application is clear to all of you? Done. Clear? Differentiation clear? All clear? Okay, let's talk about integration. Finally, last topic. It is inverse operation. It is reverse operation, not inverse. Or we can call it inverse as well, of differentiation. It is reverse operation of the differentiation. So if we differentiate a function with respect to x and we get a function this small fx, so differentiation of capital Fx is small fx. So integration of a small fx must give you capital Fx. So integration is done like this. This is the sign of integration. You write that function which you are integrating here, you multiply it with dx, this will give you fx. So differentiation of this is this, integration of this will be this. Now there is a problem. If you differentiate this function, you again get fx. Why? Differentiation of this is this, and differentiation of constant is 0. So we don't know whether there was some constant or not. So we simply put a constant with this differentiation. This kind of differentiation is called indefinite integration because, sorry, this is different. This is integration. So this kind of integration is called indefinite integration. This is called the indefinite integration. So all the formulas which we have learned in the differentiation can be directly used here. If we know that this is the differentiation of this, then the integration of this will be this. Okay. Dedication dekh rahe ho? I'm not tired at all. After 6 hours continuously teaching 3 maths topic, these are not physics topics, these are not interesting for me as well. Do you think a physics teacher will be very interested in the solving or teaching mathematical part? No, this is not about the physics. I'm not at all interested in it, but I have to teach it, and you have to learn it. Anyways, you have to learn it. So see the dedication, like I just want to complete without leaving any concept. I have to complete it as soon as possible. So what are the formulas of the integration? Again, there are some formulas of the integration as well. And very less number of formulas are there. So integration of a constant function is Cx, suppose this is C naught plus C. Integration of x to the power n is x to the power n plus 1 divided by n plus 1 plus constant, and always remember n must not be equal to minus 1. N cannot be equal to minus 1, otherwise here it will be 0. Integration of some constant into x to the power n, it will be constant divided by n plus 1 x to the power n plus 1 plus one more constant. Okay. Integration of e to the power x is e to the power x plus c. Integration of sin x. See, differentiation of cos x is minus sin x. So differentiation of minus cos x will be sin x. So it will be minus cos x plus ka c. Integration of cos x. So cos x is the differentiation of the sin x. Dx over x, it will be ln x plus ka c. So if you differentiate this part, you will get this. These are all the formulas of the integration. These are all the formulas of the integration. All the formulas of the integration are written on the right side. Okay. So let's solve some question on it. Question number 1. Integration of, what will be the integration of this? Question number 2. What will be the integration of this? Question number 3. What will be the integration of this? Question number 4. What will be the integration of this? Question number 5. What will be the integration of this? Question number 6. What will be the integration of this? There are 6 questions. Would you help me in solving these questions? So what is written here? It is 1. So 1 is the differentiation of the x. 1 is the differentiation of the x. So integration of 1 will be x plus ka c. Or there is one more method. You write it like this. You can write like this, na? X to the power 0 is 1. It will be x to the power 0 plus 1 divided by 0 plus 1. So it is x plus constant. You can solve like this also. Okay. 1 upon 2, it comes out of this, and again dx. Again the integration of dx will be x. So this is x upon 2 plus ka constant. Here the power is 1. It comes out to be x to the power 1 plus 1 divided by 1 plus 1 plus constant. So it will be x square divided by 2 plus constant. See, if you differentiate it, 2 will come out. It will cancel out with 2. X to the power will be 1. You'll get this. Quite easy. x to the power 1 by 2 dx. So integration will be 1 by x to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus constant. So the integration will be x to the power 3 by 2, 2 by 3 plus constant. This will be the integration of root x. Integration of this x to the power minus 1 by 2 dx. So x to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. So it will be 1 by 2. It comes out to be 2 root x plus constant. What about question number 6? Can you solve this? Question number 6. Can you solve question number 6? So many of you might try to solve this question like this, x to the power minus 1 dx. This is not the case. We never keep n equal to minus 1. The answer of this is dx over x is equal to ln x plus का constant. ln x plus का constant. Yes, ln x plus constant will be the answer of the question number 6. These are the few integration and the formulas. Some rule of the integration is just like you integrate one by one. So there is this question. Can you answer this question? Some rule will be used. Two functions are added with each other. So some rule will be used. What will be the integration of this? Can you solve this? So we integrate this part. 4 will be out. Cos t dt, t square dt. This will be, cos t is the differentiation of the sine. It will be 4 sin t. T to the power 3 divided by 3 plus का constant. So 4 sin t plus t to the power t. This will be the answer. C option will be the correct option. Got it? C option will be the correct option. Substitution rule of integration. Special substitution of integration. Or yaar. Then definite integration. Okay. So there are few special cases of the integration. Basic, at least you have to learn. So sin ax plus का b dx is equal to minus 1 upon a cos ax plus b plus c. Cos ax plus का b dx 1 upon a sin ax plus b plus का c. We will solve some numerical also on this, na? These are some formulas. E to the power ax plus b dx 1 upon a e to the power ax plus b plus का c dx over ax plus का b 1 upon a ln ax plus b plus का c. One more is left. Ax plus b to the power n 1 upon a 1 upon n plus 1 ax plus b to the power n plus 1 plus का constant. These are the few special cases of the substitution, and this one is used sometimes, na? Like this one is very important. I was solving a question on gravitation. This integration is required. Sometimes in the electrostatics also required. So these are the few cases, like when we use these integration. Example, if they ask sin 2x dx, so the integration will be minus 1 by 2 cos 2x plus का c. Here a will be 2, b will be 0. If they say sin 3 minus 2x dx, so minus 2 is behaving like a and 3 is b, so minus 1 upon minus 2 cos 3 minus 2x plus c. So this kind of integration we can do with the help of this formula. Similarly here, let's say somebody say cos 2 minus 3x dx. So a is minus 3, b is 2. So it will be 1 upon a is minus 3 sin 2 minus 3x plus c. Only these formulas, 5 formulas you have to remember. This one is also. If somebody says e to the power 2x plus 3 dx, then the integration will be 1 upon 2 e to the power 2x plus 3 plus constant. If somebody says dx divided by 2 minus 3x, so a is minus 3 here, compare them, it will be 1 upon minus 3 ln 2 minus 3x plus c. This will be the answer. This way we find the integration of all 5. So these are the 5 very, very important formulas. I hope you will remember these formulas. Derivation, we are not going into it because you already say no to derivations, and I don't think derivation is required, and you are very good at memorizing the formulas. So these yellow box wala formulas you have to remember. These are the basic formulas. Just 1 upon a is outside. All the basic formula, e to the power x. What happens? E to the power x. E to the power x. So 1 upon a is there. dx upon x. These are the 5 very important formulas of the substitution. Can you remember these formulas? Spatial substitution is not required. Not for NEET. If you have time, then I can teach you, but these are not required. These are for JEE Main or JEE Advanced. Like in the free time, we learn these substitutions as well, but this is not required actually. This is very difficult integration, and generally this kind of questions are not asked in the exam. Even if sometimes a question is asked in your practice sheet, then we can explain that there. This is not required. Let's move to the definite integration. Yeah, that is very difficult. Let's not go into that. So definite integration is a integration with limits. Integration with limits. So there is fx dx. So integration of this is capital Fx plus c. This is called indefinite integration because we don't know the value of c. This is called the indefinite integration. When we put the limit let's say x1 to x2. We are integrating it. So we get fx plus c, and we put the limit x1 to x2. How do we put the limit? We put first upper limit and then minus when we put the lower limit. So c will cancel out. So integration of fx dx with limit x1 to x2 will be equal to f of x2 minus f of x1. There will not be constant. This kind of integration are called the definite integration. In definite integration, whatever integration you are getting, you just put the limits, upper limit first and then minus times lower limit in the function. This is called the definite integration. Okay, let's solve a question on this definite integration. So question on definite integration is, let's say x squared dx from 0 to 3. We have to find this. Or 3x square from 1 to 3. Okay, we have to find this, the integration of this. So lower limit is 1, upper limit is 3. How do we solve this question? 3 will be out. We simply integrate it. 3 is out. Integration of x will be 3 divided by 3. This is the integration of x from 1 to 3. So we can take out this 3 and 3 will cancel out. It is x to the power 3. And we have to put limit from 1 to 3. So first we put 3. It is 3 to the power 3 minus 1 to the power 3. This is 27 minus 1. It comes out to be 26, and this is your answer. 26 will be your answer. So first we put upper limit and then we minus lower limit. So 3 to the power 3 minus 1 to the power 3 will be 26 will be the answer of this question. Got it? So there is this wonderful question waiting for you. Can you solve this question? Okay, so this is we say na ek teer se do nisane. So with this question you will be able to revise the concept of the substitution rule as well as definite integration. So this is one of the difficult problems. So try to solve this question. We will practice more problems in tomorrow's special class at 2 p.m. The link of the special class is given in the, that is pinned in the chat box. So tomorrow at 2 p.m. we are meeting again, and then we are going to solve the remaining questions which I could not cover in this class. Those questions we are going to solve in that class at 2 p.m. So let's solve this question. Can I write it like this? 3 minus 2x to the power minus 2 into dx. Can I write it like this? So there was a formula ax plus b to the power n. That was 1 upon a n plus 1 ax plus b to the power n plus 1. This was the formula. Just use that formula here. So value of n is minus 2. Value of a is minus 2 also. So 1 upon a. So a will be 1 upon minus 2. Value of n is what? minus 2. So minus 2 plus 1. Okay. 3 minus 2x to the power minus 2 plus 1. You put the limit from 0 to 1. So this will be minus 1 and minus 2. It will be 1 upon 2. So 1 upon 2. 3 minus 2x. Put the limit from 0 to 1. So first put 1. So 1 upon 2. 3 minus 2 into 1. Minus 1 upon 2. 3 minus 2 into 0. This comes out to be 3 minus 2, 1. This will be 1 by 2 minus 1 by 6. 6. 3 minus 1. 2 by 6, which is equal to 1 by 3. B option is the correct option. 1 by 3 is the correct option. Are you able to understand this? That concept which I taught you in the substitution rule here. Oh no. Here, the last one. Whenever there is ax plus b type of form, you just simply use that formula, standard formula, and just multiply with 1 upon a. Okay. Okay, application of the integration. There are mainly two applications of the integration. So whenever a curve is given, which is x versus y curve, and you want to find the area under the curve from x1 to x2, you have to find this area. So this area is given by integration from x1 to x2 y dx, or this area is given by integration from x1 to x2 fx dx. Just integrate it, put the limit, you get the area. There is one more application of the integration, and this is the last application. We will end this class because this part I can cover in the kinematics class as well. If y is given as a function of x, average value of y for x1 to x2. So average value of y is given by this formula, fx dx from x1 to x2 divided by integration of dx from x1 to x2. This concept is used in AC, alternating current. When we will need this, we will talk about this. We will cover this again, and this is all about the integration. There are some questions which we can solve in tomorrow's class. These questions we will solve in the tomorrow's class. So there is this batch, NEET Endgame, the ultimate crash course, which starts on the 2nd January. The price for the early bird is 7,999. I have already told about this course. Referral code, my referral code is Kailash 10, which you can use while subscribing on Unacademy Plus or while purchasing this amazing crash course. Kailash 10 is the referral code which you can use and subscribe to this course at a early bird price of 7,999, and you might get the additional discount with the referral code. All the faculties of this channel will be teaching in this course. This course is a revision course, again crash course. So some of the students were confused about this course. They were asking, sir, when you are already revising the concepts here, then is there a need of this? This will be in this course we will be solving some additional problems, like we have a large number of problems which we can make you solve. So apart from these questions which we solve in the YouTube and the special class, there will be few more additional problems which we will be solving in this crash course. Any of you wants to join this crash course, subscribe before 2nd of January, start learning from the first class. I'll be teaching the class 11th portion, kinematics, NLM, friction. Topics are already submitted by me. We will go into detail again, and for the detail and practice, I'll be more focusing on the practice in this course. So you can go for this course. There is one more thing. There is unlock offer also going on. Get 20% off on all NEET UG subscriptions per month. Free extension, NEET UG 2024, 2025, 2026. These are the offers. And this offer is valid till 23rd of December. Today is 21st. Same referral code can be used here, Kailash 10. And one more is Lakshya MBBS batch for NEET UG 2024. You can enroll for this also. There is Aspire, Achieve and Advance to your medical glory. Practice 10 years PYQs, all subject covered in a single test. 4200 plus question covering 110 chapters, and this is all free. You can enroll for this as well. So this class is over, and I hope you all enjoyed this class, this marathon class of almost 6 hours, more than 6 hours. I was there with you, teaching you live, and tried to answer as many queries as possible. Whatever you ask in the chat box, I always try to answer those queries. Tomorrow at 2 p.m. there is a special class. We are meeting in that special class, and we will be practicing few questions which we could not cover in this class. Only last few questions we could not cover, but apart from those questions, one of the best questions on the mathematical tool. So the previous class also we could not schedule a special class. So complete mathematical tool revision class will be tomorrow at 2 p.m. The link is given here. Join the class on time, and let's prepare for NEET 2024 with the same high josh and the excitement and the dedication which your teachers are showing on this channel. The same dedication should be shown by you while preparing for NEET 2024. Your dreams will come true once you have to work hard, you have to work smart and hard both. So we are here to help you. Thank you. Thank you, dear students. Now it's time to leave. It's already been 6+ hours, more than 6 hours. Olive, my daughter will be waiting at home. She is waiting like 10:30. I reach home by 10:30 or 11. So today I'm a little late. She will be waiting. She won't sleep until I reach there. So I have to leave now. Okay, dear friends, bye. Take care. Thank you.